All right, well, thank you. Good morning, everyone. So I'm going to be calling the meeting to order. It's at 10 o'clock this morning. I would like to welcome everyone, particularly the AC members who made it in person. We're joined by many people online as well. But we'll start this meeting by calling on Montona Futrell-Griggs to remind us of the FACA rules, and that will govern this meeting. So Montona, over to you.
Thanks, Simon. I want to remind everyone that this is a public meeting. The meeting is being recorded. By participating in the meeting, you are consenting to be recorded. We remind you that messages in the chat are also recorded, so please use the chat only for essential purposes. The Acting Assistant Director, Dr. Simon Malcolmer, is the designated federal officer for the BioAC. Please do not disclose Privacy Act protected information or any non-public information that you may receive or have access to as part of your AC member status. The BioAC has no oversight or approval authority and cannot participate by statute and NSF policy in budgets, hiring or management of NSF personnel, pre-decisional matters pertaining to awards or internal policies or management of proposals or management of bio within the National Science Foundation. The Bio Acting Assistant Director can seek the advice from the AC about many topics, including areas of scientific interest and trends in research, strategic planning in support of research, education, or infrastructure, strategic human resource development in education and inclusion, development of metrics, or strategic communication with external communities, to name just a few examples. We are looking forward to today's discussion, and I'll hand the meeting over to Dr. Iba, Chair of the Bioadvisory Committee.
Thank you, Montana. Good morning, everyone. My name is Michael Iba. I'm Chair of the BioAC. Excuse me. So I'll start with the hybrid meeting instructions. This meeting is being held as a hybrid meeting. Some of you are in the Zoom at NSF and other participants are on Zoom. For those in the room, we ask that you log on to Zoom on your computer or iPad, enable your video, but mute your computer audio. Enabling your video will allow your face to be projected in speaker view if you are presenting or in gallery view when we are in discussion. When you wish to speak, please activate the microphone in front of your seat. The red light will come on. This will project sound through the room system. When done speaking, inactivate the microphone. For those on Zoom, we remind you to mute your microphones when not speaking. If you keep your video on, this will allow your face to be projected in the gallery view during discussions. To request to speak, participants should use the raise hand feature. I'm now going to ask people to go around the table and introduce themselves, and I'll go through the names on the roster in turn. So I'll start with myself. My name is Michael Iba. I'm the chair of the BioAC. I'm the Dean of the College of Science and Technology at Chapman University in California, and my research is on microbial biochemistry and and physiology. I'll now hand over to Suzanne Barber.
I don't think she's joined us yet.
Okay. Hank Bart. Okay, Hank's not on there. Oh, you're muted, Hank.
Oh, there we go. Sorry, pushing the wrong button. Hank Bart, professor of ecology and evolutionary biology at Tulane University. My research is ecology and systematics of fishes.
Thank you. Barbara Beltz.
Barbara, you're muted as well.
Got to get into it again. Okay, I am in the neuroscience department at Wellesley College. And my specific work focuses on adult neurogenesis. I'm a developmental neuroscientist. Thank you.
Thank you, Barbara. Tom Daniel.
I'm Tom Daniel. I'm Emeritus Professor of Biology at University of Washington. My research is on the control and dynamics of movement in biology. I'm now the president of the Washington Research Foundation, a nonprofit science funding organization.
Thank you, Tom. Eric Grotewald.
Yeah, hello. My name is Eric Grotewald from Michigan State University, Department of Biochemistry and Molecular Biology. My research focuses mostly on gene regulation and metabolic pathways.
Thank you. Rob McClung.
Hi, I'm Rob McClung. I'm a professor of biology at Dartmouth College. My research focuses on plant circadian rhythms.
Thank you. Gail McLean.
Good morning. I'm Gail McLean. I am in the Department of Energy's Office of Basic Energy Sciences, where I am team lead for photochemistry and biochemistry. And I am currently the acting division director for the Chemical Sciences, Geosciences, and Biosciences division. My training is in plant molecular biology.
Thank you. Gretchen North.
Hi, I'm calling in from the West Coast. I am a plant physiological ecologist at Occidental College in Los Angeles.
Thank you. Maria Pellegrini.
Pellegrini, currently Executive Director of Programs at the W.M. Keck Foundation. And in my prior academic life, I was a molecular biologist interested in the mechanisms of protein synthesis.
Scott Santos.
Hi, Scott Santos at the University of Buffalo. I'm a professor here where my research interests are in symbioses, ecophysiology, and genomics.
Thank you. I understand Paul Turner won't be joining us till tomorrow. Is that correct?
Actually, he won't be able to join us at all.
Okay.
We got an email yesterday.
Is Maria Uriarte here?
I don't see her online. No, sir.
Okay. Kennedy Wakesa.
Good morning, Kennedy Wakesa. I'm at Alabama State University, where I serve as the Associate Provost for Academic Affairs. My research background is neuroendocrinology.
Thank you. So that was the AC members. I'm now going to ask the NSF Biosenior Leadership to introduce themselves. I'll start with Simon Malcoma.
Thanks, Mike. Yes, so my name's Simon Malcoma. I'm currently the Acting Assistant Director for the Biological Sciences Directorate. My normal gig is the Deputy Assistant Director. So I'm in this role for a little while until we can find a full-time replacement. And my training is in plant evolutionary biology.
Thank you. Teresa Good.
Hi, I'm Teresa Good. I'm the Acting Deputy Assistant Director. So Simon's deputy. I just do whatever he tells me to do. But soon I will go back to my day job, which is the Division Director of Molecular and Cellular Biosciences. And my training is in protein structure function.
Pat Serrano.
Hi, I'm Pat Serrano. I'm Division Director in the Division of Biological Infrastructure, and my training is in freshwater science and macrosystems ecology.
Jim Deschler.
Morning, everybody. I'm Jim Deschler, the Deputy Division Director in the Division of Biological Infrastructure with Pat, and my background's in RNA and cell biology.
Thank you. Alan Moore.
Hi, I'm Alan Moore. I'm the Division Director for the Division of Environmental Biology. I joined in October from the University of Georgia. I'm a professor of evolutionary biology.
Thank you. Bernice Smith.
Good morning. My name is Bernice Smith, and I'm the Deputy Division Director for the Division of Environmental Biology, and I'm about 2 months in. Came over from the Environmental Protection Agency, and I have an environmental science, environmental design, and planning background.
Thank you. Denise Deering.
Good morning. Denise Deering, Division Director of Integrative Organismal Systems. I'm a rotator from the University of Utah, where I study the nutritional ecology of mammalian herbivores. And I joined right about the time of the last BioAC meeting.
Thank you. Michelle Elakonich.
Hi, I'm Michelle Elakonich. I'm the Deputy Division Director in Integrative Organismal Systems. My background is in behavior, neuroendocrinology, and functional genomics.
Thank you. Karen Cohn.
Hi, I'm Karen Cohn. I'm the Acting Division Director in Molecular and Cellular Biosciences. My day job is as a science advisor in the Office of the Assistant Director.
Charlie Cunningham.
Hi, my name is Charlie Cunningham. I'm currently Acting Deputy Division Director in Molecular and Cellular Biosciences. Usually I'm a Program Director in the CDF cluster, Cellular Dynamics and Function. My background is in molecular immunology with a bit of parasitology thrown in there as well. Thanks.
Thank you. Now we'll move on to the Bio OAD staff. So Montana Futrell-Giggs.
Hi, my name is Montana Futrell-Griggs. I am a staff associate in the Office of the Assistant Director in Bio.
Brent Miller.
Morning, everybody. Brent Miller. I'm a science advisor in the front office, background in cell and developmental biology.
Jared Dashoff.
He's not able to join us today.
Okay, sorry, I missed that. Melody Jenkins.
Good morning. My name is Melody Jenkins, and I'm a program assistant for the BioFront office.
And Alexis Patullo. Oh, sorry, Alexis is not here. I missed that. Okay, thank you everyone for introducing yourselves. So our first item of business is approval of the September 2022 meeting minutes. We hope everyone has had the opportunity to review the minutes from our last meeting.
Mike, but before we get on to that, I think we missed Raider. We missed one in the room. It's Raider.
Good morning. I am Raider Gonzalez, and I'm the operations officer for the Bio Directorate.
Okay, thank you. Sorry about that, Raider. So thank you, Simon, for pointing that out. So the first action item is approval of the September 22 meeting minutes. We hope everyone has had the opportunity to review the minutes from our last meeting. I'll call for any comments or corrections. If there are none, I will request a motion to approve the September 22 BioAC meeting minutes.
So moved.
Seconded. Thank you, Rob. Any discussion? All in favor, raise hands. Any opposed, like sign. I can't see everything, but I assume, Montana, that the motion passed?
Yes, sir.
Thank you. The response is approved. So the next item, we're going to get into the business of the meeting. I'd like to introduce Simon Malcoma. He is the Acting Assistant Director of the Directorate of Biological Sciences, and he's going to give us a bio update presentation.
Thank you, Mike. So it's good morning again, everyone. Wonderful to see you all, and thank you for joining us in this BioAC meeting. And so we've got a packed agenda over the next day and a half or so. So let's get straight into the actual activities that Bio has been up to since the last time we gave an update at the end of September. So this is an outline of my update. We're going to start by covering some of the senior staff updates. Then we'll discuss some legislative and executive updates, some policy changes, news about programs, some science highlights, and conclude with a review of the strategic plan to set us up for the rest of the meeting. So first in staffing updates, as we've heard from around the table, it's my pleasure to welcome Bernice Smith to her first BioAC meeting as the Deputy Division Director for the Division of Environmental Biology. And Bernice, as you heard from the introduction, she joins us from the Environmental Protection Agency, where she held several roles over a few years. And before joining BIO, she did have some NSF experience, having served as on a detail in the Directorate for Social and Behavioral and Economic Sciences. So welcome, Bernice. And I would also like to welcome Charlie Cunningham, who, as you heard from the intro, is currently serving as the Acting Deputy Division Director in the Division for Molecular and Cellular Biosciences. Casonia Johnson, who was the previous deputy in MCB, has moved on to the Office of Integrative Activities here at NSF to assist with programs there. And Charlie has dutifully stepped up, taking the lead, and we greatly appreciate his efforts. And as you've heard from just going around the table, quite a few of us are in acting positions right now, which brings us to the status of the Assistant Director search. So the search continues. We were hoping to make an announcement this morning, but the planets did not align, and so we cannot announce a formal who has formally accepted the position. But we are hoping this and expect this person to join NSF in June of this year. And at which, within the next few weeks, we will be sending a formal announcement out to the entire community so that you're aware who the person is. We're very excited about the person who has agreed to join us. And we were hoping that all of the I's were dotted and T's were crossed to make a formal announcement this morning, but alas, it did not happen. At this point in time, I would like to thank Dr. Teresa Good for standing in as Acting Deputy Assistant Director and for the past several months while I've been serving as the Acting Assistant Director. Once we have a new AD, the dominoes will fall back into place, and most of the people in those acting roles will return to their normal jobs, although we still have a couple of searches that we need to initiate. We do need to initiate a search for a full-time deputy for the Division of Molecular and Cellular Biosciences. And eventually, since Pat Serrano's time is coming to an end here at NSF, thank you for all of your contributions, Pat. We will need to be initiating a search for a division director in the Division of Biological Infrastructure. So moving on to budget, as you likely heard, Congress passed the FY 2023 appropriations in late December, which included a $9.9 billion budget for the NSF. This represents a 12% increase over the FY 2022 appropriation and is the largest one-year increase that NSF has ever received. With a bigger budget comes higher scrutiny and expectations from Congress, and some of that is highlighted in the appropriations language, and also some of it in the CHIPS and Science Act that was published last year, provisions of which the FY23 funds support. For FY24, the President has released his budget request, and that includes $11.314 billion for NSF, which is an 18.6% increase over FY23, which, if it is enacted, will be the largest one-year increase that the agency has ever received. And of that, $972.41 million is requested for the Biodirectorate. The NSF request focuses on 3 pillars and 4 themes, and Bio has a role in each of those. And I've listed some of the particular instances where Bio has a larger role on the slide, including in the efforts around biotechnology, which we'll hear about more later, as an emerging industry, and NSF's actions as part of the U.S. Global Change Research Program, or US GCRP, as part of the Resilient Planet theme. And we have spent time in prior advisory committee meetings discussing ways Bio is working to inspire the missing millions and create opportunities everywhere. A reminder, though, that the President requests, and it's the Congress that appropriates. So we're still a long way to go before we see if this request does, in fact, become reality. In other legislative and executive updates, NSF is working with the Office of Science and Technology Policy, or OSTP, on its response to and actions under the recent OSTP memo on free, immediate, equitable access to federally funded research, also known as the Nelson Memo. Constituent with the agency's focus on diversity, equity, and inclusion principles and goals, NSF has been highlighting equity issues. Externally, NSF has been engaging with PIs, university administrators, professional societies, publishers, libraries, and other stakeholders, such as other science funding agencies. And in November 2022, NSF held a webinar on this topic, which was attended by approximately 400 people. So the plan from NSF has been submitted to OSTP, and we are now waiting a response from OSTP on the plan, and at which point the plan will be finalized, and we will proceed with the implementation activities which are expected to occur through December of 2025. We are also working on our actions under the recent executive order on biotechnology and biomanufacturing. So NSF led the cross-cutting bold goals and R&D needs section of the report released by the Office of Science and Technology Policy in response to Section 3A of the EO. Welcome to government, everyone. As part of this report, we outlined 6 themes of R&D investments that would spur all sectors of the bioeconomy and biomanufacturing. One of these themes is expanding the capability to build and measure biological and engineered systems, accelerating the rate of building and testing or producing engineered whole organisms could create possibilities for food, feedstock, chemicals, or pharmaceutical production. In this theme, our goals include developing new methods of biological engineering to allow for us to speed up the process of building and measuring cells and expand our ability to build to include synthetic minimal plants. Other themes include leveraging biodiversity, under which we will call for unleashing the amazing promise of biotechnology by using the diverse capabilities found in living organisms to produce new products and processes with the potential to diagnose and treat disease, develop resilient crops, create clean forms of energy, and more. Another theme was enhancing prediction and design of biological systems, which will enable creation of drugs from scratch, proteins for enhanced agricultural output, or nature-based ways to mitigate climate change. Another was advancing the ability to scale biotechnologies quickly from flask to fermenter, alleviating the lengthy process development and wasted R&D development investment. The report also called for innovation in biomanufacturing to help realize the potential of biotechnologies, increase health and enable forms of data storage, increase and computation requiring far less space and energy than conventional systems. And the report also emphasized importantly the role of ethical, safe, and equitable cogeneration and translation to ensure biotechnology advances will be embraced broadly. We're also participating in efforts to create reports on the data for the bioeconomy workforce, and international efforts, each of which responds to different sections of the executive order. And so more details on those will come in subsequent advisory committee meetings. So moving on to policy updates, there are 2 big ones of interest to the bio community. So in Chapter 2, Section D2H of the most recent NSF Proposal and Award Policies and Procedures Guide, which the cool kids call the PAPG, outlines the biosketches and current and pending support have been revised to increase standardization and to require the use of Sci-NCV for the preparation of the document, and that's going to be effective in October 2023. This will result in less workload for PIs since it's the same format that's being submitted to multiple agencies. And as noted in another section in Chapter 2, NSF still prohibits the funding of dual-use research of concern, or DURC, or gain-of-function research, that is research that uses one of 15 select agents, produces one of 7 effects, and has the potential to be misused. Research that could create enhanced potential pandemic pathogens, or enhanced PPPs, would only be allowed if the benefits of the research far outweigh the risks. And the exact requirements and details of that can be found in the PAPG. Lastly, another section of Chapter 2 describes the new requirement for the authorized organization representative to certify that an organization has a plan in place for safe and inclusive research for any proposal that proposes to conduct off-campus or off-site research. This section also provides considerations for plan development, communication, and dissemination. We also have a pilot within Bio and Geo where we're requiring a 2-page plan to ensure safe and inclusive working environments that will be that are being submitted as a supplementary document. And this is going to be to certain proposals within the certain programs within Bio, and you can that's available on the Dear Colleague letter online. And we see this as a way of Bio leading here in terms of maintaining and ensuring that there's going to be a safe and inclusive working environment for people in off-site situations. So let's talk now about some of the programmatic updates. So after careful review and analysis, and really to provide more flexibility for PIs and take advantage of the no deadline system that we have for the core programs, we have moved the Integrative Research in Biology program in Bio from being a standalone program into the core as a separate track. And there are going to be separate certain track-specific requirements, and we'll be evaluating how the community uses this track moving forward. Secondly, we are currently part of a pilot in the Mid-Career Advancement Program that allows full professors at predominantly undergraduate institutions to apply for funding from that particular program. This pilot is running for both Bio and Geo, and again, we'll report on the results at a subsequent BioAC. I've got something weird happening with Zoom. Okay. All right, sorry about that. We've all been there, right? It's been 3 years under the pandemic. We all have a Zoom snafu and not quite sure what's happening. You just need to, when in doubt, press later. That's what I do anyway. So moving on to Synthesis Center efforts. If you had not heard, we have made an award in the competition for an Open Environmental Data Synthesis Center to the University of Colorado at Boulder. The Environmental Data Science and Innovation and Inclusion Lab, or ESIL, as the center is called, will work to support team science, cyber infrastructure, education, and broadening participation. They will be assisted by Cyverse and the University of Oslo. And I will note that several of the leads of this particular synthesis center are well-versed in NSF-supported environmental research projects, which include, of course, NEON and LTER. We are in the midst of a competition for a synthesis center in the molecular and cellular biology space, and have just launched a solicitation for a center on organismal resilience. The preliminary proposals for the latter are going to be due in January 2024. We've also been doing a lot in the biodesign space as well. So there are two Dear Colleague letters that have been released by NSF focused on bio-inspired design and prioritizing interdisciplinary collaborations. So the Biodesign Dear Colleague letter allows for iOS core programs, including the Plant Genome Research Program, which aims to facilitate the translation of knowledge generated through research in the biological and engineering sciences to solutions and prototypes needed for societal and economic impacts. And specifically, the DCR seeks to encourage early-stage transdisciplinary collaboration of 2 or more investigators doing research in biological and engineering sciences with the potential for bio-inspired applications. It's also planning to accelerate the translation of research findings into projects with potential societal and economic impacts that could be ready for commercialization. And both full proposals and supplemental funding requests will be considered, but all submissions should test hypotheses about the functioning of living things that are of interest to biologists and engineers, create an iterative process between foundational and use-inspired research to create a design that solves a practical problem, and develop prototypes based on these activities as part of a process of exploring pathways to larger societal and economic benefits. So there are additional participating programs in the Biodirectorate, Engineering Directorate, and the new Technology, Innovations and Partnerships Directorate, or TIP Directorate, and they're all listed in the Dear Colleague letter. And as with any new activities, investigators are strongly encouraged to speak to a participating program director listed in the Dear Colleague letter before submitting a proposal or supplementary request. We also want to draw your attention to a new DCL that was released from the Technology Innovations and Partnerships Directorate, announcing the new tracks within the Convergence Accelerator program. And so the 3 new tracks include a track M, which is focused on bio-inspired design innovations, and it aims to bring together cross-sector teams to develop concepts, approaches, and technologies that capitalize on millions of years of innovation to find novel solutions to major societal and economic challenges. And this track was chosen based on the results of an NSF-funded community workshop on bio-inspired design. Broad topics within the track may include, but are not limited to, development of materials with features such as programmable, self-assembly, multimodal sensing, computation, memory, adaptation and healing, and regenerative capabilities. Novel manufacturing capabilities that harness advances in synthetic biology, bioengineering, nanofabrication, and 3D printing. Engineering complex systems with novel properties based on principles of synthetic biology, bioengineering, and robotics of organismal biology, including organoids, microbial consortia, and collective swarms. Computational modeling and theory-enabled methods and tools for bio-inspired design. Applications in the areas are limited, but not including, but not limited to, environmental monitoring, bioremediation and preservation, sustainable materials, biological manufacturing, personalized healthcare, resilience, infrastructure, and agriculture and food production. And as you can see from this slide, there are 2 other tracks, Track K and Track L, that may also be of interest to the bio community. So I encourage you to look at that Dear Colleague letter. The new solicitation will be forthcoming. Finally, in the area of program updates, NSF has announced the new Global Centers program, which is out of the Office of International Science and Engineering, an ambitious effort to fund international interdisciplinary collaborative research centers that will apply best practices of broadening participation and community engagement to develop use-inspired research on climate change and clean energy. The Global Centers program will prioritize research collaborations fostering team science, community-engaged research, and use knowledge to action frameworks. Awards are going to be promoting the creation of prominent, enduring international centers of research excellence that advance knowledge, empower communities, and generate discovery and innovative solutions at the regional and/or global scale. And so there are 2 tracks in this program. The first one is the implementation track, which will support the first global centers involving research partnerships with researchers in Australia, Canada, and the United Kingdom. And noting, of course, that the international researchers who are the collaborators will be funded by their respective funding agencies. And full proposals for that track are due May 10th in 2023. So you might want to get busy if you're interested in submitting to that one. Track 2 is recognizing that not everyone is ready to submit one of these large collaborative international proposals. Track 2 is a community-driven global center design, which will provide seed funding for US-based researchers wishing to coordinate efforts to design a global center for the next competition. And the proposal window for that track is April 2nd through until May 10th. And a series of office hours have been held to help the community learn more about this program. So last set of updates are the cool science bits. And so in March, NSF made an award through the Mid-Scale Research 2 program to support construction of a compact X-ray-free electron laser facility at Arizona State University. Unlike previous X-ray-free electron laser facilities, which use multi-kilometer accelerators. CXFL will be implemented in a room-scale facility with an approximately 10-meter-long beam line. The X-rays produced by the new instrument will be bright, tunable light with synchronized waves and pulse durations in an extremely fast attosecond time range so that investigators can probe the finest details of atomic interactions and molecular motion in complex materials using a range of different techniques. And this advanced design is the result of years of effort among the collaborating scientists, including prior involvement in the NSF Science and Technology Center. And if there are any questions about this facility, I will definitely be deferring to some of my colleagues in the room rather than trying to explain it myself. I've attended a couple of meetings about this and I still don't get it. And so it sounds really cool. And I know that they can do great stuff, but it's still not sinking into my thick skin. So anyway, so colleagues, just be warned if there are questions that come up about this. Some other highlights. So as highlighted in a recent Science Matters article, MCB-funded researchers published in Science Advances in December that they had discovered the 2-protein tag team that allows plants to control stomatal opening. This has implications for climate change resilience and resilience to wildland fire. The story and accompanying zoomed-in images of stomata were picked up by several news outlets. DEB funding supported research that found urban lizards share genomic markers not found in forest dwellers, as published in PNAS in September. The genetic variants linked to urbanization underlie physical differences in urban lizards, including longer limbs and larger toe pads. And an iOS Career Award funded work on glossy-winged sharpshooters that discovered how they can super propel droplets of urine, a process that could be in use to cleaning microelectronics or shedding water from structurally complex surfaces. And as our program director, Miriam Ashley Ross, said, the subject of this study may seem whimsical and esoteric, but it's from investigations like this that we gain insight into physical processes at size scales outside of the normal human experience. And lastly, DBI supported researchers engineered molecules that act like cellular glue, allowing them to direct in precise fashion how cells bond with each other. The cells contain customized adhesion molecules that bind with specific partner cells in predictable ways to form complex multicellular ensembles. This work, published in Nature in January, is a major step towards building tissues and organs, a long-sought goal of regenerative medicine. So last in science highlights, I want to give credit to our expert program directors whose knowledge has been featured in several videos produced by NSF over the last few months. So Kathy Aim, Mamta Rawat, Andrea Porras Alfaro were filmed discussing the ins and outs of fungi, including mycelium and cordyceps, tying into the fervor around the video game and TV show The Last of Us. And also, Joanne Schisler provided information on viruses for a Discovery File Kids video featuring a cartoon Joanna. And yes, Joanna, we are all very jealous of you having your own cartoon character. And then lastly, I will quickly review the NSF strategic plan, which sets the table for our discussions during the rest of the meeting. And so as you can see, the plan has 4 goals: empower STEM talent, discovering new knowledge, create impact, and excel at agency operations. For this meeting, we're going to be focusing on Goal 2, Discover. And within that goal, we want to invest in ideas, people, and infrastructure to support discovery. The 2 objectives under this goal to advance the frontiers of research and enhance research capacity. Over several sessions during this meeting, we'll be looking at how bio efforts align with strategic Goal 2 and where there are opportunities for us to better align our work. And this will include through partnerships and emergent research ideas. And so with that, I'm going to wrap it up and I'll open the floor for any questions that you might have. So thank you.
All right, thank you, Simon. If you could, even if you're in the room, if you could raise your hand in the chat so that we can, very quickly before we start, Suzanne Barber's joined us. Suzanne, could you very quickly introduce yourself?
Yeah, hi, everybody. Sorry to be late. I'm Suzanne Barbour. I'm at Duke University. I've been on BioAC for a few years, and I'm very grateful to be here. And again, sorry to be late.
Okay, and also Maria Uriarte's joined us. If you could introduce yourself briefly, Maria.
Sure. Sorry to be late. I'm Maria Uriarte, professor of ecology at Columbia University.
All right, thank you. So if you could raise your hands in the time-honored Zoom way, and then we can go through the questions. Okay, I'll start with one, Simon. So when you talked about the bioeconomy report, I think you might have had this question before. Some of the topics are kind of medical adjacent, for want of a better way to put it. How is NSF around that kind of area now when things become more medical in the bioeconomy project space?
Well, within bio, our position has not changed. I mean, we still don't want to be in a position where we're overlapping with research that's happening at NIH, simply because that is their main focus. But that's not to say that there aren't other directorates within NSF, such as the Engineering Directorate, the Math and Physical Sciences Directorate, who actually are interested in exploring some of that space. So it's a complex landscape, but certainly from a biological perspective, our position has not changed.
All right, thank you.
So I will say about the bioeconomy reports that were generated, a huge amount of credit goes to Karen Cohn and Teresa Good, who really led the efforts from the NSF side on being able to develop these cross-cutting goals that we were putting into the report. And I will say that all of the bio senior managers played a big role in weighing in on some of the directions as well. So it was a lot of work, but it was really a team effort which engaged all of the all of Bio Directorate, the entire NSF, and also our partners in other U.S. government agencies as well. So I think the next step for us is to really begin to engage a broader community, recognizing the importance of not just researchers in academia, and non-government organizations, but also industry as well, and being able to work collaboratively to move that forward. So we're still in the planning stages of how to make that happen. I see Suzanne's got a hand up.
Suzanne, yes. Suzanne.
Hi, thanks. I was really excited to hear about the policy updates in terms of safe working environments off-site and off-campus. I think that's long overdue and very much needed. Something we've been seeing in our space, even on-site, is the degree to which PIs are held responsible for being, just good mentors to their trainees. And by trainees, I mean both students and postdocs. We're getting more and more reports of, I'll call it abusive mentoring. And as you're probably aware, there's a movement across the country of graduate students who are unionizing. And the unionization effort's not just driven by money, not just driven by a desire for more compensation, but part of it is students who are really dissatisfied with the mentoring they're getting in their programs. And so, I wonder whether NSF as a funding agency, kind of having the power of the purse, has a role to play in, shall we say, encouraging PIs and institutions to hold PIs accountable for being decent mentors to their trainees.
Thanks for that comment, Susanna. I was certainly aware of the strike action in several parts of the country by graduate students and by postdocs, but my assumption was it was related primarily to compensation. It's very interesting to hear about the mentoring aspect. I was not aware of that. I know that there are ongoing conversations in the National Science Board about postdocs and graduate students and how they're engaged in research projects. I also think as well that NSF cannot go alone here. I think it's going to take a much broader effort. It's almost going to take a cultural change within the broader community. So it's not just the funding agencies, but also the researchers themselves in terms of how we move forward on this. So it's, yeah, I mean, there's still a lot to discuss in this space. I do think NSF has to play a role, but as I said, we need to have a much broader community-driven effort rather than just a single agency.
All right, Hank.
Yeah, thank you, Simon. You mentioned the executive order on the bioeconomy. What is the plan for pursuing that, and what's going to be NSF's involvement?
Well, we're still developing that. I mean, there are some programs in the works which will be coming out shortly. And but again, this is for this to be successful is going to take a large concerted effort. As I said, engaging industry, engaging academics. And it really is, again, a cultural change, because a lot of the research taken by academics is very curiosity-driven, which is important. Whereas to really make the bioeconomy successful, it's going to have to be much more goal-driven, right? And so trying to navigate that is going to be a challenge for us. But certainly we have plans in the works. Beyond the specific program that we have already, which is in the works, many of our core programs are also aligned with the goals of the bioeconomy as well. And so I do think the core programs will play a role, but there is a larger effort as well that we need to engage in with other agencies to be able to achieve those goals in a realistic timeframe.
Thank you.
Eric?
Yes, and Susan brought up the issue of mentoring, which I don't disagree with. I think it is also fair to present the other counterside of this, which is that we've all been struggling increasingly with getting good students, good postdocs. The quality of the personnel available, the availability of the personnel, and the commitment for doing science has very dramatically changed over the past, I would say, 4 years, in part driven by COVID. And I think it's really important that we consider that as we think forward how we're going to be manning our proposals.
Yeah, it's so.
We can't hear you, Simon.
I'm sorry, I forgot to press speak. So I was at a meeting in Bethesda at NIH a few weeks ago with heads or representatives of other international funding agencies. And I assumed that this was a US thing with the difficulty in attracting postdocs. It is not the case at all. This is everyone who is in attendance at that meeting was really struggling to attract postdocs. And so, again, I think, the environment has changed, and there are other opportunities available for many people. And so I think it's going to be important for us as a broader research community to make the postdocs and graduate student positions more attractable than they might have been otherwise. Quite how we do that, I don't have the answer, but certainly that seems like a primary issue that we need to deal with in the short term. Tom.
Thanks. I want to circle back to the biotechnology, bioeconomy future thing. I think it'd be interesting for bio to put a bit of a stake in the ground on this. And particularly, I'm going to say something a little challenging, but the world of AI right now, which we're all thinking about, is predicated on a deep understanding of natural intelligence. And that's something we don't actually have a good understanding of. I'll start there. Secondly, is the compute energy being thrown at AI is that of a small country at this point. So it's a massive, massive energy demand. And the third thing is natural systems compute with orders of magnitude greater efficiency. We have to get an understanding of this, but it has a direct impact potentially on producing bio-inspired, maybe bio-based computing. So I just want to put that out there as a stake in the ground, because this directorate is uniquely poised to lead there. That was a bit of a soapbox.
No, that's great. Tom, Michelle, you wanted to comment?
Well, so one of the most recently funded AI institutes is in that area, and bio is co-funding it.
All right, thanks. Maria?
Yeah, I'd like to circle back to the difficulty in attracting postdocs, students, and also touch on a issue that Suzanne brought up of unionization. We have seen at my university incredible increases in the cost of postdocs and students, both driven by unionization, to the point that what was a normal budget in the past is no longer feasible. And that also, we also have mandates from the union to provide, certain rates of increases on stipends and salaries, and that is really completely out of our control at this point. And I wonder how many of these efforts that are happening across the country are changing salaries in very substantial ways, and what that means for the research enterprise in terms of the number of people that we can support. So it's something that it would be great if NSF could get some kind of handle on what is going on with these efforts and what it means for the budgets.
Well, we're certainly engaging the community broadly to keep updated on what's happening with these particular efforts. And the guidance that we're providing to all PIs is that any budget that's going to be submitted to NSF, none of the core programs have a cap to the budget. You should be submitting a budget which is realistic to be able to support the graduate students and postdocs that you wish to employ on that particular award, recognizing it's going to be a large budget. But we have to be realistic. We cannot continue to be underpaying these people who are going to be being trained as graduate students and postdocs, because it's unfair to them, and it is also unrealistic as well. And so, in the short term, it's difficult for us to manage this, but certainly moving forward, I would hope that everyone submits a realistic budget on what it's going to cost to be able to support that, and also recognizing that maybe we need to rethink the number of people who are engaged in a particular project, because but again, that's a decision for a PI and an institution to make rather than coming from NSF.
Right, but on the other hand, I think, I hate to say this, but the whole science enterprise is predicated on access to cheap labor, which is the students and postdocs. So if that's not the case, what does that mean, for NSF? So that's also a larger question for NSF of what would it mean to have as much a smaller workforce, and what would it take to support, what kind of science? Maybe the answer is, to engage more AI, or I don't know what it is, but I think we need to think about this before it hits us, because many of us are confronting that right now. And it's not just a matter of having a larger budget, but what does it mean for the science enterprise in general?
Absolutely. There are definitely knock-on effects, and I think this is a much, much broader question. And again, just to reiterate what I was saying before, I think NSF has a role to play in this, but it's not going to be the person who's going to be dictating what's going to be happening in this particular space. It's going to take a much broader coalition than that.
Rob.
Sort of a pragmatic follow-on to that is it used to be, in the olden days before unionization, one could safeguard oneself by saying, well, I'm going to pay NIH scale. Is there right now, everything's being developed rather ad hoc, local unionization efforts. And I must say, I don't have a lot of faith in the economic forces driving this to some sort of equitable solution. Is there any discussion among the agencies of coming up with new guidelines that are more consistent with the need to pay a better salary, that would at least standardize it, perhaps put in cost of living, the same way one's per diem is prorated? Is there any thought of doing that?
I think everything's on the table, Rob, and the National Science Board is actively discussing this as a topic. But again, it's fairly early stages, but we're not ruling anything out at this particular stage.
I think that I should have added at the start, we're going to try and bring some of these issues when we have the round tables. And I think this is clearly, so I'll just add a comment. What I thought was interesting is I think people like Maria in New York, us in Southern California, assume that it's a cost of living problem. But now when I hear that it's across the country where the cost of living is less, it's very difficult to imagine implementing a lot of these plans without the workforce to do it. I kind of had assumed that people would move away from the coasts to do this, but I think that turns out to be a very naive idea of mine around this. But I don't think we can. Sorry, Simon. I know you want to think about big ideas in the workshop, but I think we're going to have to try and add something about this to our discussion, because we need workforce to do the big ideas, unless we go Tom's way and just have AI take care of it for us, which seems quite operable. Tom, I was going to ask if there are any last questions before we move on to the next item on the agenda. Tom.
I want to defend myself. I'm not saying AI is replacing our postdocs, but I also wanted to follow through that this issue of recruiting excellence and paying for excellence and diversity is a great spot to talk about when we come to public-private partnerships and public industry, public philanthropy. I think that's a space where both philanthropy and industry has a vested interest.
Great. Thanks for that. And yes, this is an ongoing topic of conversation. So, I would encourage you to bring it up with Karen Marangel and Brian Stone when you have that conversation with them tomorrow. I'm sure they would like to hear your perspectives.
All right. We've got time for one last question before we move on, if anyone's got anything. Otherwise, we're good. All right. Thank you, everyone. I thought that was very productive. So if there's no other questions for Simon, thank you, Simon, for that presentation. I think that set us up really, really nicely for the rest of the meeting. So we're now going to move on and discuss the bioresponse to a couple of COV reports. And we're going to start with the bioresponse to the Division of Molecular and Cellular Biology, Molecular and Cellular Biosciences COV report. So in May 2022, the Division of Molecular and Cellular Biosciences hosted a committee of visitors. Rob McClung was the AC representative on that committee. And at the full BioAC meeting, Rob presented an overview of the COV report. Bio has reviewed the report and has provided a response. I would like to invite Charlie Cunningham, Acting MCB Deputy Division Director, for his comments. Charlie?
Thanks, Michael. So the MCB Committee of Visitors visit covered the years FY18 through 21. It was held over 3 days in May of 2022. It was chaired by Elizabeth Still, who's University of Alabama, Birmingham, with 17 members in total. And there was representatives of industry, there was other government agency, and there was different types of institutions that MCB serves represented on the committee. So I'll say first off that there was no major red flags, I think I can say, in the report, and there was a number of compliments. I'll just read 3 of those. MCB did an excellent job of addressing issues raised during the previous visit in 2018. MCB is a premier agency that champions outstanding science and in developing workforce, and MCB is poised to raise the profile of NSF as a leader in addressing national scientific priorities. Nonetheless, the executive summary of the final report did have a list of 10 recommendations, and there was also additional suggestions in the body of the report. Here, I'll just focus on some of the steps we've taken to address the committee's recommendations and suggestions. So the committee suggested that MCB should develop longitudinal metrics to track the impact and the success of funded projects. And Bio agrees, and we're aware that MCB stakeholders are increasingly looking at the impact of MCB funding decisions. And so to this end, MCB has established the Forecasting Future Data Working Group, and that's charged with exploring the use of different portfolio analysis tools. And here we look to Brent for help. To complement the MCB Programme Director-led design of funding opportunities and implementation of funding decisions aligned with NSF strategic goals and priorities. And then the second part of the charge was really to propose how to measure the impact of different strategic goals and sub-goals, either from the NSF strategic plan or MCB priority goals. So that working group is actually due to report to MCB senior managers in the next 2 weeks with their recommendations. All of the working groups I'll speak about were stood up by Kasonia, the Deputy Division Director, I think round about the fall of last year. Second point that the committee made was they expressed concerns about the reporting of broader impacts and suggested that MCB might explicitly ask for an extended retrospective accounting of broader impact activities and new proposal submissions from any PI that has had previous funding from NSF. So asking for retrospective accounting and a new proposal submission is a little difficult for MCB, as NSF policy for proposal, which is laid out in the PAPG, gives guidance about what can be included in the results of prior support section as well as the broader impact section of the proposal. So that limits what we can actually specifically ask for in the actual new proposals. But we have stood up an annual reporting working group. So each funded PI, as I'm sure you all know, has to submit an annual report. And that group reported last week. They provided 9 recommendations for program directors. Now, again, what goes in the annual report is covered by policy, so we can't dictate that. But what we can use the 9 recommendations for is for when we have our one-on-ones with PIs, when we do virtual officers, any communication, we'll use those nine suggestions from the working group to communicate to the PIs exactly where in the annual report that we hope that we will see them expound more greatly than they normally do about their broader impact activities. It should those recommendations from the working group should also serve as a metric for the expectations of the program director for the broader impact information that they should expect to see in the annual reports. And really, it does vary across annual reports how much gets reported. And so it should then be a pointer for them about when to return annual reports for more information. And then the third point I just want to highlight is about communication with stakeholders, especially new PIs, minority PIs, declined PIs. The Committee of Visitors said that needs to continue and it needs to improve. And actually, since the COV was held, there's been a change in practice in how we handle declines. And as a result, a marked increase in the use of a function which is within eJacket called the PO comment function, where we can communicate directly when we make a decline. We can communicate directly with the PI team. And that's become much more used, especially in proposals that have reviewed poorly. The change that's been made is that for proposals that are ranked non-competitive or low priority, we no longer write a review analysis for the proposal, but we do insert a mandated PO comment saying, please get in contact once you've digested the contents of the reviews. So MCB, what we have done is that we have stood up an outreach assessment and strategic planning working group to align the outreach activities to the division's science and training priorities, and to identify metrics for assessing the impact of MCB's outreach activities. and to develop a pilot an outreach assessment program. So the group was also asked to come up with a coordinated plan for targeted outreach and by small interdisciplinary teams of program directors. And what we're looking for, we hope, is a multi-year plan of small teams, say one from each of the clusters within MCB, to travel to states that are underrepresented in our portfolio. And within NSF at the moment, there's an emphasis on moving funding to EPSCoR states, so that would certainly be one target, as well as PIs and institutions that are underrepresented in the MCB portfolio. So we'll be getting a report out from that group later this week. And then finally, the COV made a number of suggestions regarding the core solicitation. They felt that we needed to define what MCB meant by theory-driven research, as that could mean different things to different people. They also observed that the cluster categories are broad and don't reveal the composition of the portfolio and the subdisciplines that comprise them. So in common with all the core solicitations in bio, the MCB one was updated in January 2023. MCB took note of the committee's recommendations regarding theory-driven. That language was updated to clarify our intent, and we updated cluster funding priorities and also emphasized those priorities in outreach materials and in our virtual officer presentations. So I'll just leave it there.
All right, thank you, Charlie. So we don't do Q&A in this part, so we're just going to move on. So the second COV was to the iOS. So we're going to discuss next the bioresponse to the Division of Integrated Organismal Systems COV report. So in spring 2022, the Division of Integrated Organismal Systems also hosted a committee of visitors. Scott Santos was the AT representative on that committee. And at the September meeting, Scott presented an overview of the COV report. Bio has reviewed the report and has provided a response. I would like to invite Michelle Elikonich, iOS Deputy Division Director, for her comments. Michelle?
Thank you. We're grateful to the Committee of Visitors for their thorough and thoughtful efforts in evaluating the management and review processes in iOS during fiscal years 18 to 21, and for their complimentary report. iOS was part of the NSF-wide broadening participation pilot, broader impacts pilot, and had additional broader impacts expertise on the panel among the 12 members from across the iOS scientific areas. We want to extend a special thanks to Chair Hannah Carey. Suggestions from the COV fell into several themes. We especially appreciated the COV's recommendations to advance our efforts to broaden participation, including engaging more with postdocs, beginning and early career investigators, and PIs and potential PIs from MSIs, minority serving institutions, EPSCoR states, primarily undergraduate institutions and master's granting institutions. Multiple COV recommendations requested iOS address implicit bias and improve transparency in the review process. The COV also made suggestions of additional analyses for the next COV self-study regarding the review process, analysis of broader impacts efforts, and integrating more information into the self-study from the NSF-wide evaluation and assessment capability section. I'll note that for every one of the last 4 COVs, and COVs occur every 4 years, we've had additional analytics capability available to us as our ability to understand our internal data has increased. And so I fully expect that some of these requests about the next self-study will be easily fulfilled. Several COV recommendations relate to NSF-wide and federal government policies and guidelines. such as how broader impacts are evaluated and reported and how voluntary demographic information is collected. In these cases, we'll convey the recommendations to the appropriate groups within NSF. In the COV response document, we describe specific details for our plans aligned with their recommendations, and iOS has begun to implement some of the activities described in the document. For example, we recharged our outreach working group, which is led by our new science advisor, to focus on engaging the community in additional ways as suggested and broadening participation activities. And they're currently focused on engaging with postdocs to connect them to NSF early on and give them additional resources for their career transitions. To address implicit bias in review, we have added additional information and links to NSF's video entitled The Art and Science of Reviewing Proposals that is available to all reviewers, which covers bias and the review process. And we've added that to the letter inviting reviewers and in the panelist appointment letter, as well as encouraging panelists to view it prior to the pre-panel meeting. We've also added discussion of the goals of societal impact of potential bias and the differential effects of the pandemic to our panel welcome. And we've updated the slides on bias that we used during the introduction of panels to train the panel. To reduce the time pressure, a known contributor to bias, we have provided dedicated panel summary writing time at each panel, and we've updated the panel summary template to provide additional information about what should be covered and make it more accessible for those who are colorblind. So in the past, the template had some of its instructions in colors that really didn't show for some people. To improve transparency around our review processes, we've completed and we've planned additional virtual office hours and blog posts in the areas suggested by the COV. And they were very, very complimentary about our virtual office hours, which iOS originated early in the pandemic and have been well attended. And so we've done a blog post already about responding to prior reviews. And we are working on one about the panel summary template and how it's used during panel. We've posted a blog about how broader impacts are reviewed in February, and a more detailed broader impacts blog in March. We have posted blogs and held virtual office hours about PO comments, and like MCB, we're part of the pilot to use PO comments rather than an RA for lower reviewed proposals. We also have posted blogs. One of the suggestions was about making iOS science more visible. And so we have been working with Jared Dashoff in OAD. So you saw the cartoon Joanna, which, gosh, I really wish I had a cartoon Michelle. You saw the cartoon Joanna and other things like that, but we have been also doing a blog post to share with our PIs an effort by our Office of Legislative and Public Affairs called Science Happens Here, NSF Stories, and encourage them to participate. And a blog to remind them that when they have new great things coming out, that they should please let us know about them, because we'd like to help tell the world how wonderful iOS science is. We have also posted and talked about annual reports, what goes where, how to do them, and we're updating that blog regularly. And our virtual office hours also upcoming, I believe it's in June, will have meet the program director time so that the community can get to know their individual program directors more easily.
there's quite a few other things that we have planned, and we'll be seeing those engagements roll out in the future. So again, we're very grateful for all the input and all the positive support that the COV has offered us.
Thank you, Michelle. Does anyone have any comments they'd like to share either with Charlie or Michelle about their responses to the reports? In that case, I'd like to thank both Charlie and Michelle for their responses to the reports. They were very, very informative and very kind of uplifting. So now, in a very un-NSF kind of way, we will have an extremely long lunch break. So we will now take a break and resume at 1 p.m. Eastern. Zoom participants, please stay connected to Zoom, but turn off your cameras and mute your microphones. All right, thank you, everyone.
Especially for those of you on the West Coast, so you can actually have a probably.
Simon indicated in his remarks, the framework for this meeting is NSF Strategic Plan, which is a continuation from what we started at the last AC meeting. So I'm now going to turn to Teresa Good to introduce a presentation from BIO on how BIO is aligned with Strategic Goal 2, discover by creating new knowledge. Teresa.
Thanks, Mike. So you've heard now a couple of times what we mean by Strategic Goal 2, but just as a kind of remind you that NSF's new strategic plan has 4 strategic goals, 3 of them to do with science, empowering STEM talent, creating new knowledge, and then delivering impact by translating that knowledge into solutions. And so as we dive deeper to address that strategic goal 2, creating new knowledge, we're going to ask for your input on where the leading edges of science are and where should we invest in discovery or other parts of that creating new knowledge. And just as a preface for that, NSF frames creating new knowledge as part of how we promote the progress of science so that the nation remains a global leader in expanding discoveries in science, engineering, and learning, and that we build the capacity in the nation for scientific, technological, and economic leadership in a competitive world. So, as you think about creating new knowledge of our universe, our world, and ourselves, we are thinking about that in two themes: the advancing the frontiers of research through accelerating discovery and strategic investments in ideas, people, and infrastructure, and enhancing research capacity, advancing the state of the art and research practice, such as collaboration, interdisciplinarity, reproducibility, thinking about new modes of research, convergence, open data, links between curiosity-driven and use-inspired research, and the like. So with that, Denise and Alan are going to give you a little overview of what we do in BIO to discover Goal 2. So Alan and Denise.
Thank you, Teresa. Can you hear me okay?
Yep.
Okay, thank you. Yes, Alan and I are going to tag team this presentation. So I'll be running the slides, and just give me a thumbs up that you see the slides. Yep, great. Okay. So with that, I'm Denise Deering, Division Director of the Division of Integrative Organismal Systems, and I'm joined by Alan Moore, Division Director of the Division of Environmental Biology. And we have a short presentation for you on how we achieve Goal 2, which is discover and create new knowledge. Alan.
So in case you were confused, we're talking about Goal 2, discover. But this puts it in context of the 4 things that NSF has identified in strategic plan of where they are putting their effort and thinking. In BIO, our goals are to look about to discover life, the principles of life. It's small goals. Advance the frontiers, and to provide theoretical basis for prediction, which is very important. Next slide. Just a bit of background. It's always fun to have some stats to look at. Last year, we've evaluated over 4,000 proposals, funded over 1,000 of those for 27% funding rate, 416 different institutions, over 14,000 individuals. We don't just fund individuals, fund institutes, common sites used by multiple researchers like NEON and LTER, and we partner across international boundaries, NGOs, and domestically. Next slide. This is a slide, and I think this is a very interesting slide in the sense that it shows the funding based on per capita, which shows you that not only do we fund all 50 states, but the funding per capita is not the same as the amount of money that goes to each state. So you can see that some of the states that are less populated do just fine, and some of the very populated states are in the middle, which is kind of nice and shows the distribution of the funding that comes from bio. Next slide. So the directorate is organized under kind of traditional thinking about biology, from scales of organization, molecules to genes to proteins, on up through organisms, community, ecosystems to bio. Okay. Can you guys hear me? Yes? Okay. That was strange. So we look at different levels of organization. So we have different directorates: the Molecular and Cellular Biosciences, Integrative Organismal Systems, and Division of Environmental Biology. In addition to that, biology uniquely has a division that funds people and institutes and structures to help facilitate things. And then we have a virtual directorate of Emerging Frontiers to stimulate new ideas. Next slide. The reality, however, is that that isn't really the way things work. Because of common techniques and tools, the questions that are being asked in the different divisions are actually using the same sorts of tools and looking at similar sorts of things. So DEB, for example, may be looking at molecules. MCB does not just limit itself to reduction to science and may look at evolution of cells and proteins, for example. So really and truly, the divisions interact extensively and overlap considerably. More reflective of the Division of Biological Infrastructure, which of course covers all of biology and emerging frontiers. Next slide.
So in the next few slides, we'll introduce you to our core programs, and this is where the bulk of our funding goes. And the core programs represent incubators for PIs to generate new science ideas. And as Alan said, the work in each division is structured around questions. So on these next few slides, I'll show you the questions that are being asked in the different divisions. So in our first division of Molecular and Cellular Biosciences, which supports research to decipher the molecular underpinnings of living systems, the types of questions that are addressed in the core programs are: how do cells function and why do they function that way? How do genes and genomes evolve? How does the structure of molecules impact how they interact? How can synthetic or engineered systems help us understand biology? In Integrative Organismal Systems, where I'm the director, we support research to understand organisms as units of biological organization. And the types of questions that are being addressed there are: how and why do animals behave the way they do? How do organisms develop across their lifespan? How do brains pick up and respond to stimuli? How do organisms move, and how is that impacted by body structure? How do plant genomes impact yield, resistance, and other traits? Now I'll turn it back to Alan, next slide, who is the director of DEB.
So the Division of Environmental Biology supports evolutionary ecological research So this involves species, populations, communities, and ecosystems, but the tools that are used, again, to emphasize, are very common across all of the different directorates or different divisions. Next slide. So how do different parts of an ecosystem interact? How do they impact the function of the overall system? How do organisms evolve? How do that evolution to solve different problems, different environments that the organisms face? How do environmental changes impact the populations and organisms? And how are organisms both living and extinct related? So basically, it's a division that looks at variation. Next slide. Division of Biological Infrastructure is interesting. It supports the development and enhancement of biological research infrastructure, physical, cyber, and human capital. And this is interesting because it really facilitates the research that goes on in all the different divisions. So how can we support biological sciences workforce, the development and training of that workforce? What tools and infrastructure do we need to move biology forward? And what team or community-wide centers and facilities are needed to bring together individuals from different research perspectives? Next slide. Emerging Frontiers is exactly what it says. It's a virtual division in the sense that there's no director of it. It's run out of the office of the assistant director, but it's really there to kickstart new things and to facilitate new ideas and innovations, interdisciplinary research, and networking activities. Next slide.
Okay, so we are good at collaborating across divisions, not just in slide presentations, but in science. And in this slide, I'd like to give you examples of 4 programs that are cross-cutting across bio. And these do not represent all of our special programs, but there are 4 existing programs. The last 2, organismal responses to climate change and long-term ecological research, you'll hear about in other sessions. So I won't emphasize those any more than to give you their titles. And I'll talk more about the other 2 programs, starting with building synthetic microbial communities. So we know that microbes have remarkable biological diversity that allows them to flourish within every environment, including within a variety of hosts. Researchers now have the ability to assemble synthetic microbial communities that have novel compositions and also functions, and can use these communities to address fundamental biological questions and a range of societal problems. The goal of this program, Building Synthetic Microbial Communities, is to support research that addresses one or more of 3 themes. First, defining the underlying mechanisms that drive the formation, maintenance, or evolution of synthetic microbial communities. Second, using synthetic microbial communities to address fundamental biological questions. And third, building synthetic communities with applications focused on biotechnology, bioeconomy, or environmental engineering. The second program that I want to highlight is called Building Research Capacity in Biology. And all 4 of our divisions participate in this. It's led by the Division of Biological Infrastructure. So while talent is often said to be randomly distributed, we know that opportunities are not. To address the NSF theme of opportunities everywhere, this cross-bio program is focused on enhancing research capacity and broadening participation of new faculty of biology, specifically at minority-serving institutions, predominantly undergraduate institutions, and other institutions that are not among the nation's most research-intensive. It aims to broaden participation by expanding the types of institutions that submit proposals to bio, and expand opportunities to groups underrepresented in the biological sciences, especially those at under-resourced institutions. Program officers from all 4 of the divisions serve in this program. And the Building Research Capacity Awards, which are up to $500,000 for 3 years, provide the means for new faculty to initiate and build independent programs by enhancing their research capacity. Goal is to enable the establishment of sustainable research programs for faculty and to also enrich undergraduate research experiences and thereby grow the STEM workforce. And in the past 2 fiscal years, there have been 42 awards made across 17 different states. So we know that tool development often drives new abilities to discover and understand life's complexity. And I want to give you 3 examples of tool programs in bio. The first one is called the first one is called Dark Dimensions of the RNA Regulome. And this was an ideas lab that recently catalyzed the development of new teams of awardees who are exploring the wealth and complexity of RNA-based processes. RNA has become an increasingly interesting focus of study due to new discoveries of its multifunctionality in cell systems. Second program that I'll highlight is called Designer Cells. And this program seeks to understand and apply basic knowledge to generate new novel units that could be used in biotechnology applications. And the third tools program that I would like to discuss comes from a special program entitled Enabling Discoveries Through Genomics, or EDGE. And within the EDGE program, there is a tools track. And I'll take a moment to highlight one particular tool that was developed through the EDGE program. And this tool has the clever name of Remote Control, where remote stands for receptor-mediated ovary transduction of cargo. And this tool was developed by Jason Raskin's team at Penn State. And it enables researchers to genetically modify an egg-laying organism by connecting the gene editing reagents to egg proteins. And the figure that you see on this slide compares and contrasts the remote control system to the traditional injection system. And I won't have time to walk you through all the details of the figure, other than to say, with remote control, a simple injection into the blood or the hemolymph introduces the gene editing reagents and with high efficacy, and in doing so, bypasses surgery and microinjection into the embryo, as is found in the more traditional gene editing approaches. The Nature Communication publication describing this NSF-funded research has been accessed tens of thousands of times since its publication in 2018. This application has been used in arthropods and holds promise for any egg-laying, egg-bearing species, including vertebrates. Research in bio includes many outside partners, and we're looking forward to your input along this front in the breakout groups. So I'll start by highlighting a couple of programs for which we have outside partners. The first one is Accelerating Innovations in Biomanufacturing Approaches, and this is a partnership with another federal agency, the Department of Energy. You'll hear more about this in another session, so I won't dwell on it too much now. The second partnership is to advance conservation science, and this is a partnership with a philanthropic organization, the Paul G. Allen Foundation. And in this partnership, NSF funds the basic science, while the Paul G. Allen Foundation funds the conservation portion of the research. And you'll hear more about this tomorrow. So now I'll turn the mic back to Alan, who will tell you about the third partnership.
Well, we don't just partner with a single organization. And so from the Paul G. Allen Partnership to one of the ones that has been going for over 20 years now, Paul G. Allen has been 1 year, less than 1 year, is the Ecology and Evolution of Infectious Diseases. This is an interesting and fun partnership that partners internally with multiple directorates, bio, SBE, geo, math and physical sciences. It partners with other U.S. agencies, NIH and NIFA, USDA. And then it has international partnerships with Israel, China, and the UK. And just as a note, one of the interesting things about this, well, there was a question of how do you differentiate between NIH and NSF science. And in this partnership, if something is deemed to be fundable by NIH, they fund it, not NSF. So if it's a human-oriented NIH-type project, then it's funded by NIH, but run through a single competition. The international partnerships, again, they'll fund in their own countries. So the goal of this program is to emphasize predictive principles of pathogen transmission using quantitative, mathematical, or computational models. Very important that there be prediction and not just modeling what has happened, but trying to get at what happens with the reemergence or the increased transmission of pathogens. All species, all environments are included, so not just humans, but non-humans, plants, microbes, any environment you might think of. This program has run for over 20 years now. It's had over 200 awards, and 34 different institutions have been funded by this program. Last slide. And with that, we're happy to take any questions or any clarifications you might want.
All right, thank you, Denise and Alan. So that was, I think that was very, very helpful. As they both said, this is going to set us up for our breakout rooms and further discussions. So do people have questions? Everyone just wants to get to the discussion, I guess. Oh, Maria. Oh, wow, yeah. They're coming in now. All right, Maria, first.
Hi, thanks for the presentation. So I have a general question for program officers about what are the parameters, for instance, for sharing funding amongst, federal agencies or, with sort of private institutions in terms of what NSF can and cannot do. That would be helpful for us, I think, as we discuss, ideas.
So just to clarify, your question is are there entities we would not collaborate with? Is that right?
That's one part of it. And the other part of it, for instance, you mentioned that NIH will fund human aspects of research, or you may have a collaboration with USDA. So what are the, sure. What can we fund and, from the NSF perspective, and what are the limitations that
Well, the practical way this works is that they have program officers in the room when the panel meets. So there are people from NIH, there's people from NIFA there. So they're hearing the debate and the discussions, and at that point they make a determination of that looks like science that we would fund. And there's a discussion between the program officers on, first of all, is this a project we want funded? And then secondly, who would take up that funding? And it's done very collaboratively. I don't think there's, well, it begins with an MOU. So there's an understanding of what sorts of things the different entities are looking to fund and how they're going to work together. So it isn't just invite somebody into the room to listen to panels and maybe you'd like to fund some things. So it starts with developing an MOU and an understanding.
So Maria, it's important to recognize that the clear parameters on what is going to be acceptable for a particular program are going to be spelled out in a solicitation. So we want to make sure that it's transparent to the broader community. It's not the situation where we get a proposal and then we shop it around to different agencies after it's already been submitted. And so that comes back to Alan's point about having the MOU and also having representatives from the other agencies in the room. In terms of just the human science aspect, we recognize that, as I said earlier today, that NIH has a number of investments in that area, and there's no way that we can compete. We have a lot of other biology that we can support. So if there are programs in the NIH space already, then that's not something that we would consider pursuing simply because our funds are better invested elsewhere. But in terms of and again, we also factor in other agencies such as USDA, NOAA, all of these other agencies as well, simply because they have investments in that space. But in general, curiosity-driven research in bio, as long as it doesn't cover human applied solutions to cure disease, and I can probably say that better, but it's that we're open to supporting any kind of biological research like that.
Sorry, Hank. Sorry, I always do that.
Make sure I push the right button this time. Yes, so my question is about the BRC biology program. I was looking at the synopsis, and maybe it's just the way I read it, but I thought it was primarily focused on minority serving institutions. It also includes, I read, institutions that don't normally compete effectively for NSF funds. But can you just give me a sense of how much of the funding reaches the minority serving institutions? Do they have to do the PIs or the bigger universities, some of which are getting funding, have to have collaborators from the minority serving institutions? Just a general kind of question about how that money is being distributed to both, big institutions and not so big ones. We cannot provide specific percentages about a particular program. Okay. And we can do it at the directorate level, but we can't go below that. But what we can say is that the BRC Bio program is focused on emerging institutions, including minority serving institutions. And from an internal perspective, we're very encouraged by the demographic information that's being shared.
Okay, Maria?
My question has to do with the portion that we were talking about in terms of tools. I thought it was really interesting that the funding of the mosquito ovary modification, but I'm thinking that there are a multitude of new methods and techniques that need funding, and they are often, I think, the most risky because there is no preliminary data. You're trying to develop something like that, and I'm wondering if there's going to be more emphasis on that in the future. New tools, new methods.
Did you want me to take that, Simon?
Yeah, please. I would encourage you to take most of these questions. I'll just step in as needed.
Okay. We can't really talk about what is happening in the future, but we seek your input on these sorts of topics. Like, what sorts of tools would you like to see developed in the future?
Well, one of the things that that I see a lot at the Keck Foundation has to do with new sensors across the board, and the development of new sensors usually, again, is without preliminary data, and so that's at least one area that I see that and again, because I see so many applications in that area, and many of them have been turned down by NSF.
So along the lines of sensors, we do have a new program within the Convergence Accelerator that is run through the TIP Directorate, and that's a chemical sensing tool program that is based on existing biological tools. Michelle, did you want to add anything to that?
Can I jump in? Right. So Maria, there are many sensing programs across the foundation. Within engineering, there are a biosensing program within kind of the chemical engineering division, and there's also a sensing program within the electrical engineering division. That within the mathematical and physical sciences, there are sense programs that would develop sensors in chemistry and in materials research as well. And so as you are talking about sensors, I think given, to help us understand what you're really looking for in terms of kind of more support for sensors, is it interdisciplinary research that would enable you to sense in a biological system, or is it using biology to sense something? And that will help us understand where you're going, and would it fit within something we would do, or would we partner elsewhere in the foundation in order to accomplish that?
Well, again, my experience is just people who come to us and have been turned down, and it's across the board. We see especially a lot of biosensor types of projects. So.
Right, and I would just say that the engineering program is pretty oversubscribed and perhaps modestly funded. So that's nothing we have any control over.
Okay, thanks.
Yeah, I just wanted to, sorry, Mike, sorry, this is Karen. I just wanted to add one thing because I heard Maria mention the word risk. And I wanted to just say that a number of our divisions fund tool development through the EAGER mechanism, so the early concept grants for exploratory research, which really is a mechanism that's intended to, to tolerate some level of risk. So Maria, in the context of trying to develop new tools, when you don't have any preliminary data and you just want to test the tool or test your ability to develop a new tool for a particularly important application, that is something that could be proposed to our individual divisions using the EAGER mechanism. Over.
Okay, Suzanne.
Thanks. I was fascinated by the per capita map of bio investments. Really quite fascinating. Looks very, very different than if you don't normalize per capita. I wonder, do you see similar, or have other directorates done that sort of analysis? And if so, do they see the same kinds of distributions? You may or may not know, I'm on CIOS, and we put together a report about EPSCoR last year. And, the focus was, we need to start thinking more about geographical diversity and the degree to which investments are spread across the country, but we didn't use this lens. So I think this is absolutely fascinating, and I hope it's not the only directorate doing this kind of analysis.
No, in fact, it's really simple. If you go on the NSF website, it'll say Inside NSF. You click on it, and it's an interactive map. You can get all the numbers underlying it. It's really very cool, and it's seconds to get the answer. I'm sorry, NSF by the numbers. NSF by the numbers, and it's publicly available. And you can do it by directorate, you can do it by NSF, you can do it by multiple directorates, really whatever you want. And I really encourage people to go look at it, because I do think, to Suzanne's point, it is different in the different directorates, and it is different when you look at it per capita versus dollars versus number of projects. And so you can get some real insights into how things are going, depending on how you look at it.
Thanks, Alan. Do you know, are other directorates doing this kind of analysis, though? I mean, I assume that you all are going to deploy these data in some way. I wonder if the other directorates are taking a comparable approach.
We're all kind of looking at each other right here in the room, just vacantly to ask if another directorate is doing this. I think there's an opportunity here for the other directorates, but we don't know of any specific examples to share, unfortunately.
All right,
and
thanks.
I put the NSF by the numbers link in the chat for you.
Okay. Barbara.
Yeah, hi. I was also curious about the BRC program, and just wondering, how a beginning investigator decides between that route, or if they're at a PUI going into an RUI kind of proposal, or REU, I guess, proposal. Are there mentoring aspects to the BRC that would then lift some of these people up to the point where they're more competitive for other programs, or what makes it different other than the focus itself, on these particular groups?
So, Barbara, let me take a shot at that one first, because we were very careful in the way we just designed the BRC Bio program, because a lot of people, when they're initially starting at emerging institutions, the startup funds they have are quite limited, and so they need some additional funds to be able to generate those preliminary data, to be able to engage undergraduates or graduate students in their research program, to then generate those data which then would be competitive for an RUI proposal. And so the structure that the BRC proposal's analogous to what you would expect in a RUI proposal. And so it really is that stepping stone to hope that, to be able to get them that kickstart that they need early in their faculty career, to then be able to come in for a RUI and then hopefully then have sufficient preliminary data to be able to sustain their career long term.
Okay, got it. Thank you.
Can I add something very briefly? So Barbara, I was really interested in this. So I was part of a review panel, and I think what really distinguishes it is it was targeting institutions where there's potential but not enough capacity for research, and that was one of the driving criteria, which I think quite distinguished it from the normal RUIs and others as well. Kennedy.
I had a follow-up question to that. So when you talk about this faculty at MSI or POIs who are getting funding from this program, have we tracked them to see whether they do move from those individual mechanisms to other type of funding mechanisms over the years?
That's the plan, but I think we're in year 2 right now, and so no one has finished their BRC Bio award just yet to see what happens next. But it's, clearly we need to track this, and it'll be important to see if the plan is actually realized.
Tom.
I have a question for program directors, both two who presented, but others.
Tom, we can't hear you. No, still nothing. Can anyone else hear Tom? All right.
So we need thawing infrastructure. Are you back?
Tom killed it, unfortunately.
Are you guys okay? Can you hear Michael? Okay.
Yeah.
I was asking the program directors, is there some large scale infrastructure that would be of significant impact to bio that's not there? And what struck me in Simon's first presentation was this room scale advanced light source. It's not an X-ray, which has the capacity to image, I'm assuming, protein in solution, which it's that sort of scale thing I'm wondering about.
So we're really worried about what happens when APS goes down.
It's down now.
Yeah. Yeah. No, I mean, there aren't that many other light sources, right? And so, and we've been funding through the mid-scale program a number of high-end NMRs to do structure. So, but there's always a lot of interest in the mid-scale program, that there's, and I think that there are far more worthy ideas out there than the money that we have. So, and
Common
I think-
theme.
Yeah.
Okay, do we have any more questions? Or is everyone eager to start the discussion? I think you're all eager. So I have to say, I think those numbers per capita is very encouraging. So more money for California, was that the conclusion I got from that? That was good. Okay, so what we're going to do now, if there are no further questions, is we're going to go into the breakout groups. So you should see, if you look in the chat, that Montana has started to add in the details. So we have 3 breakout groups on Zoom. If you look in the chat, 1 will stay in the current room, and then groups 2 and 3, they're not the breakout rooms that you may be used to, where you go within this Zoom. You either leave or pause. So Montana, one clarification: would you like us to leave this Zoom, or would you like us to pause in this Zoom and open in another Zoom? Do you have any preference?
You're gonna have to leave the Zoom and open the Zoom link that I sent to you. I sent by email, and then I'll also put the link in the chat. It's just something with the webinar feature that we could not create breakout rooms today.
All right, so if everybody is ready, I'll just go through some details of this then. So we're now going to break out into smaller groups to discuss the emergent research areas where bio can support the strategic goal. So we have 3 rooms in total, and when everyone is in their virtual and physical breakout rooms, a scribe should be chosen to capture the key points of the discussion. In your breakout groups, please consider these questions. And we've discussed this before the meeting. We want to stay focused on these and not get too far out. So the first is to really think from above, what are the most exciting or impactful research that is emerging for biological sciences? And the second question is, what are the factors, new approaches that are required to advance that research? What are barriers to advancing it? And again, the goal here is to think at a higher level about this. It's not to sort of try and propose specific or even broad funding mechanisms for NSF. That's what NSF are good at. That's what they do. Our goal is to simply look at factors that might help advance research. So as one example, it was brought up this morning about the need for example, ways to maintain the workforce. That's something we'll talk about broadly without thinking about detailed implementations and how that relates to the bioeconomy. That's for the funding agency. So the scribe should take note of the exciting research areas and any factors that are required to advance the emergent research or barriers that prevent advancing the emergent research. And I think the barriers point is key. We have to get both of those in there. So at 2:45 Eastern, we'll have a break to transition back to the main room, and then we'll have report outs from the different groups at 3:15 Eastern. So remember to consider the memo you received prior to the meeting in addition to what you already have heard today. So I'll let Montana say a few words, and then we'll go to the breakout rooms.
Because this is a FACA committee, an NSF staff member must be in the rooms with you while you have your discussions, but we will not be a part of those discussions. If you have any questions, please email me or reach out to me via Zoom.
Okay, does anybody have any questions before we go to the breakout rooms? Oh, we're in the breakout rooms. Okay, see you on the other side. In your breakout rooms, I think we solved the world's problems in hours, so I hope the rest of you are similarly successful. So what's going to happen is we're going to ask each breakout room to report back. If you can keep this down to maybe 7 or 8 minutes or so, we just have half an hour for each in total until we move on to the next item. What I would like to ask, if that's okay with the NSF group, is that if the scribes from each of the rooms could send me a summary, your take-home points, because I'm going to try and pull everything together to start putting putting together what we'd like to talk to the Deputy Director about when she visits with us tomorrow. Is that permissible, Montana? Is that okay?
Yes, that's fine.
All right, thank you. All right, so if you could do that, the scribes, just send those brief notes to me. I'll put I'll put something in the chat along with my email address. All right, so let's get right into it. Maybe we could start with Group 1.
Sure.
Who would like to present for Group 1?
Yeah, I was the scribe for Group 1, so I'll try to summarize what we discussed. For the first question, what is the most exciting or impactful research that is emerging for biological sciences? We talked first in general about applications of artificial intelligence in biology, questions related to model reductions of these very high dimensional problems, translation of genotypes into phenotypes, global climate change models, generally studies of process and how can those be used, benefit from the artificial intelligence tools. Also, in that same context, at a larger scale, thinking about natural intelligence and cognition, and artificial intelligence is still relatively clunky with respect to energy efficiency. And I think there would be something we discuss how natural systems, like for instance, honeybees were brought up, can do cognition in a much more efficient way. So what can we learn from nature for the application of AI? That seemed like an exciting question too. We also talked about remote sensing tools and how they allow us to look at processes both at a large scale, for instance, understanding below ground processes at the planetary scale, and how that can give us new insights into the planetary resilience, and also at the nanoscale. So that also seemed like a really exciting area of research. We discussed multi-scale dynamics in biological systems, things like the integration of physiology into population, communities, and ecosystems, the relationships between molecular cell and organisms, and also the integration of humans and the environment, with a particular focus on bidirectional scale issues that involve both spatial interactions and temporal interactions. So how, for instance, do we integrate physiology, physiological responses of organisms to temporal variation in climate into a particular outcome with respect to demographic processes or population processes? So that seemed also that it was a promising area of research. There were two additional points. One is, I think we're getting ahead of ourselves a little bit. The study of climate change is primarily focused on natural systems, but there's also the issue of effects on agriculture, which is huge, and how we can use AI to advance this field, and also collaborate with agencies like the USDA in applying basic science to problems of kind of sustainability of our food systems. And then finally, the climate aspects of the NSF portfolio appear to be entirely focused on mitigation, and a much more kind of diverse and difficult area of research will be adaptation to climate change, which is also realized more applied and perhaps somewhat outside of the purview of NSF, but it's an area that needs a lot of attention because mitigation is not going to be enough. So what can we learn about adaptation, both from natural systems and from human, the interaction of human natural systems? So those were the question one. And then question two, which was what are the factors or new approaches that are required to advance that research or are barriers to advance in it? We identified the usual suspects, which are computational resources, the lack of quantitative skills, both in statistics and computation in our traditional biology education. And then we had a really interesting discussion on sort of ethics and liberal education, and how there is a need to train students on the sort of ethical implications of the research, and that somehow falls by the wayside. And a number of us were concerned that this has become even more of an issue with COVID. So graduate training programs have been very focused on kind of skills and responsibilities, but not so much on kind of what do we owe each other, right? Like what are our responsibilities to humanity, and how do we convey that to students that are now addressing these problems that are really central to the well-being of humanity. So we think that's an area that perhaps is ripe for some kind of collaboration with the foundation, because we realized that we were kind of delving into the humanities. We also discuss sociological barriers that we face as scientists, a movement from PI-driven science to team-driven science, and then sort of understanding how do we create and work on teams, what is an effective team, how we make sure that these teams are representative of the diversity of institutions and perspectives, and how do we get feedback from end users, whether that be industry, farmers, or any kind of recipient. And again, I mean, this is something that is addressed now in the solicitations offered under the guise of project management, but it tends to be fairly sparse. And it's an area that, given the multidisciplinary nature of many projects, is going to require attention and perhaps some research itself of how do we create effective teams. These are things that we learn on the job, and managing a team effectively is difficult. And so that's one of the other issues that we brought up. And then also kind of like creating more kind of hands-on research. Again, in the context of the pandemic, it's become even more important that we provide students with hands-on research that engage them with technology, that engage them with real things. So how do we foster that? And we think that's essential for advancing science also. So I think that's all I have, and please, the team members, chime in if I left anything out.
All right. Thank you very much, Maria. I think at least we had quite a bit of overlap with some of the things, but there were also some really different things that we didn't think about. Okay, so were we room 2? Is that correct? Okay, we were. So I'm going to report out for room 2. So we did also cover quite a lot of similar issues. So in terms of question 1, what is, there goes my headset. What's exciting and impactful? We as a kind of, and this is somewhat overlaps with question 2, but what we think is exciting is looking at methods as discovery-based research opportunities. So new methods and digging into new methods and coming at things in unexpected ways, we think is something that should be done more of. For us, one of the ultimate examples is imaging, in so much as you can't have this as hypothesis-driven research, but advances in imaging allow us to see things we couldn't see before. And so we think that whether it's direct imaging or indirect imaging or other methods are clearly something that needs to be driven forward without simply asking if we know what the answer will be if we ever have the method to ask it. I think that there's 2 sides. We thought there were 2 sides to this, that you have method-driven and needs-driven method development and technology development. We thought that's important. And we're seeing this in different areas, and we want to see more of this. So one great example is in one of the explosions of RNA biology has been based upon new methods that enable us to look for things. In some cases, we didn't think were very important. And then once we had the method to look for them globally, we saw how important they were. So the other big issues for us was using AI in what we think is ways that perhaps is not undervalued, but is underutilized, is this idea of re-examining existing data with new technology that didn't exist when the data was originally harvested. So whether this might be by AI or by other methods. And part of this is an exciting area where we feel that a growth area for impactful research is to truly push interdisciplinary research that addresses skill gaps. Because a lot of interdisciplinary research right now assumes some level of overlap, even if it's minimal overlap between the participants in the group. And some of the most exciting things are where you have people who really don't have any overlap and they can bring new things to the room. Something that we think was somewhat taken for granted, but we think there's a lot of space to do, is the kind of driving the next steps in microbiome research. So some of this is around fundamentals, whether it be advancing understanding of how we make microbiomes. Our knowledge of how to create a microbiome is still very, very basic, and we think there's a huge area for growth there. Again, understanding microbiomes by using new technology and using AI. So as one example, people are now utilizing AlphaFold together with existing structured databases to try and predict metabolic networks using metabolomics in a microbiome. So the idea here is that you can do reconstruction without having to know how every enzyme in a complex system, what its kinetic parameters are, for example, that you can start to be predictive about a system. And it's this ability to be predictive, which we think is a huge area. So this then relates, this idea of true integration of being predictive, to NSF have had a lot of success on what defines a phenotype. We do think that now moving more into what defines traits, how you build a phenome, is very, very important. And this relates a lot to what Maria said about climate change, because one area where we really don't understand is adaptation on timescales, which the components of the systems have not evolved on those timescales previously. And we don't know their adaptive ability, we don't know their ability to acclimate, and we don't know their ability to endure changes outside of the expectation of a natural time frame. So it's this idea of an unimagined man-made time frame and how it impacts a system. And being predictive in that space is very, very difficult, if not impossible currently. And that seems to be an area where there's a lot of potential. The final area we thought was interesting is sort of the next generation of synthetic biology. Whether this be synthetic genomes, synthetic organelles, using synthetic biology to recapitulate and test evolutionary hypotheses. Currently, a lot of synthetic biology, you use it as a system to evolve rather than using it to test existing hypotheses. And also to look at its potential in different synthetic settings. So one example that came up is the recent work on synthetic synapses and things like this. So this exploratory version of synthetic biology is sort of the next step. So for question 2, we think that actually there are new approaches that will enable some of this. So when we think about students and postdocs, we thought that we need to better define how we provide more robust career development, advancement, and successful outcomes as part of the student and postdoc experience. Whether this might require us to think about different research hierarchies where we don't simply have students, postdocs, and then this gap to the faculty position that might enable people in this space. And this sort of obviously relates to mentoring, to career development and career opportunities, and building a robust group who we don't define their outcomes, we simply give them options as they come out of this. I think that's another aspect. The final thing we brought up is what we see as a barrier to advancing many of these things is a poor understanding of what risk is in a research environment. We tend to regard risk in a way that we see it as a problem rather than an opportunity. And we'll come back to this, I think, in the second session tomorrow. As venture capitalists, when they look at what risk is, they're looking for 5%. 5% of their investments will return something, the others won't. We know that's not something that, as one of our groups said, Congress would ever be particularly pleased to hear. But if we want to be innovative and and do these new things, then I think there has to be an ability to reassess risk. And it may be something that's simply outside our comfort zone and our expertise as academics to properly assess. So that's where we got to. Did I miss anything? Okay, thank you, Hank. All right, if there are no further comments, I'll hand it over to the third group.
Okay, I was the scribe. And in fact, the things that we talked about, most of those have already been mentioned. We focused on how biology can basically be used to create or help to create solutions for climate change. And then a second theme that we ended up talking about mostly as an overlapping theme of using neural networks and AI to promote solution-based science as it applies to climate change was our specific discussion. So basically the question is, how can biology help us understand and progress with climate change problems? And our discussion was based on the idea that a lot of basic knowledge is there, and we're creating more of this all the time, but that the translational tools lag behind. And so we discussed how prediction and modeling based science and AI could fill that translational gap. And so issues that we discussed, as Mike just mentioned from his group, that we really need to focus on prediction testing and based on basic biological principles, less empirical testing, more modeling, validating those models with a few examples. And we spent a lot of time thinking about funding mechanisms in a few different ways. One is about how those mechanisms could bring together basic biology with people who can translate those data into predictions and solutions. We talked about workforce development, but struggled with the tension between training individuals with breadth between all of these areas or among these areas, but then potentially losing the depth that might be necessary to actually solve some of the problems. But nevertheless, thought that people with hands in both biology and in neural networks or AI would certainly be helpful in order to improve communication. And we thought that really there is a gap in communication between these groups because the translational part really isn't very well put together so that people can understand and appreciate the biological questions related to climate change and how to create testable models. I guess the fact that we all exist in silos, or for the most part often do, but that this is not productive when we need to synthesize information among these different areas to create solutions. We also had a lot of discussion about how our current funding model focuses on short-term projects. Researchers focused on gathering data to support short-term questions, and then go on to the next iterative questions, and instead needing solution-based approaches and longer-term horizons. So we thought the current funding model should be flipped on its head, basically, to have solution-driven proposals and then reverse engineer the issues and the answers. We thought potentially interagency funding that does focus on solution-based types of proposals in various areas would potentially be the best way to approach this. And the review process, we thought, needs to basically set new priorities and not be risk averse, and consider much longer timeframes in order to encourage the types of questions that we need to address to really successfully get at climate change. So I guess just to summarize, what we need are overarching programs to address a combination of biology as it contributes to climate change and modeling / AI training in multiple areas with translational goals and softening the silo approach that we have now, facilitating effective communications among the different players, workforce development to train people that can talk to multiple groups, and changing the funding mechanisms from data-driven and risk-averse to solution-based and embracing risk. Yeah, we were talking a little bit about NSF Center's approach. The longer-term approach is probably what we will need for the climate change issues, and applying AI approaches to those. All right, other things, Eric, Gail, Kennedy?
Okay, thank you. Thanks, Barbara. Okay, so I think we have everything there. So we have some time just at the end of today before we adjourn for the day, just to bring some thoughts together for Karen. But I think Karen Mangel, but I think we have some pretty consistent themes which will be good to point her to and to get her feedback on. So if there are no further comments, I think we can move on to the next item. Are Kim and Ben here, or should I wait a little bit? Sorry, Gretchen had a question.
Yeah, actually, it was just a comment, and it's just a small part of group one that was, it was a new consideration for me, and so I'm just going to toss it out there. And that is that maybe, and we were talking about our inability to attract and keep good graduate students, good postdocs. Perhaps one problem is the dilation of the educational period required, and we were talking about perhaps we might appeal to a broader group of people and retain them if the education period were shorter, and perhaps looking at graduate education as somehow being streamlined.
Okay, Tom.
I just want to riff on something I heard in the last, Group 3's presentation on the emphasis of models and data. There is a whole emerging field called physics-informed neural networks and models, PINs. And that is that typical neural networks, people use your data and a neural network and train it on your data, but there's no constraint imposed by the mechanisms that you understand. If, for example, your data had to follow Newton's laws, you would have to constrain the neural network according to mechanistic structures that you have envisioned. So I think as the different domains of NSF move forward with modeling, data, and neural networks, think about the new literature coming out of physics on PINs, physics-informed neural nets. It's how you implement your model as a loss function. It's really awesome. So, sorry, just a little riff.
Eric.
Yeah, and I think commenting on that, I think physics are a little bit better wired than biologists to be able to interpret models, abstract models very often. I think that one of the struggles that biologists are finding is that The models can be generated. We just don't know how to use them.
So I'll add something to that. So I'm on a team where where they've worked very hard, and it speaks to something that Maria brought up a little bit, is team science. So it's going across different NSF divisions into social science and other areas, because team science I had no idea what a thriving space it was, and integrating that into biology, into modern biology, where you have these teams, is really, I think, is really key as well. Okay. Do we need to just wait a couple of minutes for Ben? I don't see him on the list yet. Oh, there's more questions. We don't have to wait. Maria.
Just a brief comment of something that I left out. So to the degree that it's possible with the current institutional structure, students have, often are much better than we are, kind of like team-based things. I don't know if it's a generational thing. But there is currently like no way, all the funding that is directed to graduate students is individual funding, either through the GRFP. Is there some way for the National Science Foundation to funnel money to graduate students that are thinking about these kind of team efforts, whether it be representation in science or even scientific problems, even if it's at a small scale? I think that would be a great kind of training ground to educate students on how to do team science and to seek funding way before they get to the postdoctoral or PI stage. So the thought.
Rob?
I just wanted to return to something that Gretchen was saying. A number of us, I think probably everybody, has been talking about the extension of the training period, and how we're seeing that as a deterrent to go on. Yet there's a heck of a tension there, because of course we've just now heard passionate pleas for enhanced mathematical quantitative training, physical training, etc. And so, I mean, it seems we want our cake and to eat it too. And I think this is one of the big challenges we face. How do we train a competent workforce in less time?
Okay, so if there are no other questions, I think we will move on. Our presenter for the next session is here. So thanks, everyone. I think this is, like I say, I think it's been really, really good. I really like this model that we used. So, get my script back. So next on our agenda, we're going to hear from the Advisory Committee for Environmental Research and Education. The ACERE was established in 2000 to provide advice, interface with the scientific community, serve as a forum, provide broad input, and perform oversight on interdisciplinary environmental and education research supported by NSF. We're joined by Kim Jones, Associate Provost for Faculty Affairs and Professor of Environmental Engineering at Howard. And she's going to provide us with the update from the ACERE.
Thank you so much, Michael, and thank you to the entire advisory committee for allowing me a few minutes today to come to you. I've come on behalf of the Advisory Committee for Environmental Research and Education, where I serve as chair. And I have a few slides that I hope will provide some context for what I hope to bring. So hopefully you can see my slides. So ACERE, as was mentioned, is an advisory committee for environmental research and education. And one of our initiatives that we've been working on lately we're calling Sustainability of Science. So first I wanted to give you just some context about who we are. We are a cross-agency, we work across disciplinary boundaries at NSF. And so we work with an NSF work group with representatives from different directorates. And the thing that brings us together is we all are interested in research or education involving the environment. So for example, I'm an environmental engineer. but we have other members of our committee with very different backgrounds. So we span across many directorates, many different kinds of backgrounds. And again, what brings us together is an interest in research on the environment or in the environment. A few of our current initiatives are here. Over the past couple of years, we've been working on broadening participation in environmental research and education, centering environmental equity in research activities, improving interdisciplinary collaborations, water availability and security, and what I want to talk to you today about, and that's minimizing the environmental impact of research. So we've called our initiative on minimizing the environmental impact of research, sustainability of science, because it means it can be summarized as SOS, which we thought was interesting. But really, it is really to try to get researchers to think about how we can minimize our impact on the environment. So some background, we know that the corporate sector is measuring and setting targets for environmental, social, and governance performance. And so this whole idea about what are we doing and what is the impact of our activities on the environment has been gaining a lot of traction in industry. Also, we know that there are science-based targets for reducing greenhouse gas emissions, so that's something we should be concerned about in general. Our current administration has said very clearly that some priorities include reducing environmental harms, striving for a net zero future, and advancing environmental justice. And so in the context of that, we were wondering whether the scientific community, specifically at NSF, those funded all or in part by National Science Foundation, are we doing our part to provide a forward-thinking approach to sustainability practices and minimizing its own environmental impact? And so in particular, we mean the environmental impact of researchers conducting their work. And so we did look at what's going on at NSF currently, and we were able to figure out that there's some, in the strategic plan, there's a need to involve what constitutes or promotes responsible conduct of research, and also highlights a profound challenge posed by global environmental change. We know that all research activities and facilities supported by NSF come with some environmental impact, including a contribution to climate change through direct or indirect emissions of greenhouse gases. There are a couple different ways that NSF considers environmental impact. We can prepare an environmental impact statement to meet NEPA regulations or for NEPA compliance. It's a very specific type of statement that would have to be developed. Also, we can advance sustainability plans for facilities in certain cases. Not all researchers have to do that, but for certain facilities that is necessary. And for certain types of proposals, there's an environmental impact checklist that we found that researchers have to fill if their research meets certain criteria. And I'm gonna show you what that looks like. This is what the checklist looks like. It's called the Environmental Impacts Checklist. And if you will be prompted to complete this checklist if you check any of the boxes on the right hand of this sheet. And so if you do certain types of research, which are pretty narrow, and probably a relatively small percentage, I'm guessing, of researchers actually would meet the criteria. But if you meet any of those criteria, then you'll be prompted to complete this form and document the impact of your research on the environment. But if you don't check the box, then you would not need to submit this. And I know I've been funded by NSF. I've never had to check this box, for example, despite the fact that I do environmental research. And so I believe that some researchers have to do this, but probably not many of us. And also, NSF has conditioned PI. So we all do our intellectual merit. We think about broader impacts. I know when I'm on review panels, when I think about my own research, I tend to think about NSF research anyway, and those two in that way. And I'm used to thinking about what are the positive impacts of my research? What are some of the positive broader impacts of my research, right? I don't necessarily think always about what some of the negative broader impacts may be. And one of those would be whether or not my research has a negative impact on the environment. And so what we've been doing about this, our fall meeting and our spring meeting, we dedicated some time to discuss environmental impacts of research, just of our types of research, and what we thought would be an appropriate way to increase visibility and awareness of this issue. So we spawned an interest group to explore it in more detail. I'm a member of the interest group along with Ben McCall, who's really the leader of our group. Unfortunately, he could not be here today, but he's a professor of sustainability at the University of Dayton. We have Vicki Gracian, who's at UC San Diego, who's a professor of chemistry and biochemistry. She does a lot in green chemistry. And Arnaldo Val Levinson, who is our executive secretary. He's in Geo and he's on loan from University of Florida. And so our broad consensus of our interest group and of our committee as a whole is that this topic is important and it warrants increased awareness among PIs and their institutions and also within NSF. So we know that we do have some influence on the environmental impact of our work. We can decide whether or not to attend a meeting in person or by Zoom, even though we know that, and we learned this during the pandemic, that even virtual participation has some potential environmental impact. We know that some universities have ways, very, very easy ways for investigators to get help in thinking about or considering sustainability issues and minimizing the way they treat waste, for example, or to think about which kinds of chemicals they may use for their research in order to have a minimal impact on the environment. We do have a concern, though, because in thinking about equity, if we were to think about, we talked about a couple different things. We talked about perhaps having a statement, and this is what I want to talk to you all about today too, but I just want to, you are advisory committee number 4. So we've talked to a few other advisory committees and we've been getting input along the way. And so some things that, some suggestions we've heard are, for example, can we have PIs write a statement in the broader impacts piece, for example, or should we have a separate document, much like the data management plan, for PIs to fill out about their environmental impact of their research? And so those are some things that we thought about, but in this, we do not want to place any additional burden on the PI. And we are very aware of that very critical and small 15-page limit for many proposals. So we don't want to take up a lot of space. But at the same time, we do think that it's very important to increase awareness and visibility of this issue, particularly as we engage students in our research, because we would like students to be aware of these issues and to really start to think about them a lot more. And so I'm just going to put all of these up here at once. Here are the questions that we were hoping that we could discuss in the remaining time that we have here. I don't know if I saw an agenda, but I think I have 30 minutes. I'm not sure, but if so, hopefully we can spend the next 20 minutes or so in discussion about this. And so these are the questions that I'm hoping we can discuss. I can leave this up or I can put the questions in the chat. I already see a couple hands, which I hope is a good sign. So that is all I have to present. I wanted to spend the rest of my time just hearing about what you think about all this. So I will, if it's okay, I'm not.
Yeah, thank you, Kim. That was great. Yeah, you're a model of timing. You have 20 minutes left for discussion. All right, so I'll start with Hank.
Yeah, thank you, Kimberly. That was really outstanding. Definitely something we all should be paying attention to. And I hope maybe we did lose the opportunity to really get a grip on just what kind of impact research is having during the pandemic. Because, if we continued to do research, but not at the rate that, the travel and all that stuff was curtailed. So I think there was a lot that could have been learned from that, but I don't know how we're going to do that now. The question I had is, whose responsibility is it? Is it institutions' responsibility? Is it part of their responsibility, because they accepted the grant to do the research, or is it NSF's responsibility for funding research? I think these are important questions that have to be answered. And But it's just like everything else related to climate change. We can't ignore it. We have to take into consideration and figure out how we're going to minimize it. So,
great comment, and I agree. We did kind of talk about where the I don't want to call it a burden, or where the who has a responsibility. I view it as a shared responsibility because, again, if we're doing research, we should be aware. Our institutions should be a lot more thoughtful about ways that, or resources they can present to researchers for minimizing the impact. And also NSF, has a role here and an opportunity, I would say, to really, and this is what we're hoping for here, is to see this as an opportunity for NSF to raise awareness and have some way where researchers would automatically, I won't say automatically, but we required to really think about this as they, at the same time as they design their research methodology.
All right, thank you. Maria.
Thank you, Kim, for presenting this issue that I think a lot of us think about but don't know quite what to do about. And so it's great that you bring this out in the open. So I guess my comment is somewhat related to Hank, but it's slightly different. I wonder the degree to which this could be an effort to ask institutions and individuals to do things that they're already doing. For instance, with respect to raising awareness of environmental impacts of research, oftentimes, NSF requires, for instance, if you're working on state land or federal land, that you have some kind of permit. And those permits often involve, some assessment of impact. And so it could be as simple as just including a document that outlines what is already happening. From the point of view of institutions, I think it's really complicated. I live in New York City, and trying to bring buildings up to speed, buildings that are historical often, and complying actually with the things that the city is asking already, everybody that is in New York to do. I think it's something that perhaps could be done through the Office of Research of the institutions, just requiring that there is some consideration of what are the environmental impacts of research, because that's a really hard thing to do, retrofitting buildings. If new buildings are a little bit different, but again, that's outside of it's an institutional issue of how do you build and what's the environmental impact of research. And so I think that's also something that is probably already there in some form, and that, NSF could ask the institutions to provide some kind of narrative so that the responsibility does not lie with the PI, because I just worry about the increasing number of requirements from the PI, and oftentimes we're not equipped to address this question. And then the third issue on the individual PI responsibility, I'm very torn. It's, for instance, the need to travel. I think we're still kind of grappling with the consequences of not being to physically be able to see our colleagues and to do things remotely. And even though clearly the environmental impact of flying, I work in Puerto Rico, so I have to fly. What are the pros and cons? And I think it's an individual kind of decision that we all make, but I don't know that we understand enough about what it means to be virtual for the research enterprise. And I don't know if there's efforts out there to kind of think about this, but I think it's a big, big issue. And something to consider as we, how will this affect your ability to interact with your colleagues, productivity, and so on. And for young people, I think it's even more so. So just some thoughts on different scales of responsibility that these issues are important, but how we go about them, I think it needs to be, especially at the individual level, I think we need to be careful. And thank you so much for that.
Thank you. Those are important considerations, and I just will comment really quickly that we consider all those things you thought about, and I guess what we're trying to do is try to figure out what is most reasonable. So this is where we do need your input. What is most reasonable for some way to have the PI? We don't want to shift all the responsibility, as you said, to the PI because we don't want this to be a burden. But for institutions, we do know that, as we think about it, some institutions are really well positioned to do this, are already doing it. So a PI at a well-resourced institution that's ahead of the curve with this will be able to just simply say, oh, our Office of Green research or whatever is they're handling this, and they have a canned statement that they use. Whereas another university,
I see a big competition developing among institutions.
we don't want to have an issue around equity. And so we did also say that we didn't want this to be, we weren't thinking about a recommendation that would have this environmental impacts as a criteria for determining if a proposal would be funded, but rather it was just something that we wanted to just, kind of raise awareness. So anyway, I just wanted to, and your comment about the impact of travel on students is another one that we really talked about, because we don't want to come out and say, for example, let's minimize travel whenever we can, because that can have some negative impacts on our research and the way we do our work. So that is and we're trying to minimize impacts, right? So we can never get to zero, but we do want folks to just really think about steps they could take to minimize it.
Eric.
Yeah, thank you, Kim. As an individual, I think about these issues all the time. Okay, and I see no way of solving the conflict of just by being, I'm having an impact. But I'm trying to understand a little bit more where this is going. Is this kind of an intellectual exercise? Or is this really something where we expect to be making fundamental changes in the way we operate? And what would be incredibly helpful for me is to kind of put some dimensions of this. And dimensions in the context, for example, of saying, yes, university so has this impact, which is comparable to the impact that is, I don't know, I live in Michigan, to what Ford has on the environment. Okay, because at this point, I really have no idea as to whether the impact that all the NSF-funded research has, is it even, is it just a kind of a differential of the impact? So I think from the perspective of awareness, it's a great exercise. But from the perspective of practicality, I think it's very dangerous to be making recommendations that may hinder or slow research at a time in which research is probably what's going to be solving these problems, just because we're trying to solve kind of a differential problem in the climate kind of a problem. So thank you very much for that. It's just, I think about this all the time. I just don't know what if the solution might not be worse than what we have already.
That's a good comment, and we have been trying to get data, and we'll see how much we can get on. It's hard to quantify. We pulled a couple of research articles where we try to look at really what is the impact of research on the environment. Most we'll talk about either, they've looked at, for modelers, for example, like, power for, if you have these big, if you're doing a lot of computer work, they've kind of been able to figure out what the impact of that may be. But for those of us, I'm an experimentalist. So for those of us who are kind of going to the lab and doing our work and, how could we understand really what the impact is so that we could try to figure out how to minimize it. And so we have been trying to get some guidelines. Last week, I'm also on the advisory committee for engineering, and I presented to them last week. And one thing they asked for was just some guidelines, really, how to start to even think about this. So what we're hoping to do is really maybe and that's why we're going to each advisory committee. If you have any examples that you can give us, if you've already thought about it, and if you've made any headway, if your institution has made any headway or anything like that, we would be happy to hear about it. And also, before I forget, on this slide, and I'll drop it in the chat when I finish, there's Ben's email. And after this, if you want to drop an email to him and let him know what your institution is doing or your thoughts, please feel free to do that. But we are trying to hear from each community, for the bio community, really, how does what do you think are the main ways that your researchers may negatively impact the environment? And are there some ways that you would consider guidance for minimizing it? So that is another thing that we're hoping to get, because and we are working in the background, and we'll follow up in some way once we can get our hands around any information on what are the current impacts or some way to quantify it, because I do think guidance would be helpful. I see some more hands. Can I just call on the people I see? I don't know
Yes,
if-
Tom, sorry. I was
Okay.
trying to think of my own question. Tom, I'm trying to phrase it. Sorry, Tom.
Thank you for the presentation, Kimberly. It was really good. I have three things. Thing one I'll start with is I would be reluctant to put anything more on PIs than we already put on PIs. I'll start there. At the same time, it would be very interesting, and I think you alluded to this, for the PIs to understand the impact. It's very difficult for them to tell you what it is until they understand it. So for example, do the 50 ultra low freezers or the greenhouse, what are the real energy impacts of the things they may be using? And if that could be, at least if some of the data can come forward to the PIs, that may help them inform you about ways to go forward. So what are the big energy hogs in experimental science, and getting the data forward to the community might be useful. And the third thing, which is the one we heard earlier, is the design of research infrastructure. It's really hard to retrofit, but there are really brilliant new building designs coming out that support very as environmentally friendly a research infrastructure as you can get, which includes things like where you locate your ultra lows in a building relative to the HVAC. All these sorts of design criteria are established, but they're hard to implement without funding. And in the infinite dollar budget of NSF, I would encourage partnering with institutions and states that sponsor those in updating and retrofitting and even new science infrastructure for both learning and research.
Thank you.
Done.
That's a good comment. I'm gonna limit my counter comments to you all because I realize we're running out of time, and I do want to make sure I get all of your comments. So, Kennedy.
Right, Kennedy. Yeah.
Thank you for that presentation. I think you kind of touched upon this, the idea about talk about retrofitting buildings or the responsibility of institutions, especially minority serving institutions or institutions that do not have that much funding. And also institutions that use multiple events in one building. So I'm thinking about our life science building. We have classrooms in the same building. We have research labs. It's a combination of different activities that are happening in one building. So how do you go about it? Dissociate the research aspect from the teaching aspect and the other events that are happening in there.
Good point.
So I'll be very, very quick as well. To Tom's point, I think that some of the idea of telling people the environmental impact of different activities, but to what Eric said, I think the framing of it can. So Suzanne Barber isn't here, but Suzanne has kind of brought this up before, that there's actually the more environmentally conscientious ways of doing big team science are actually if you require people to have mechanisms in place for remote interaction, you're actually more inclusive of people who can't so easily travel or institutions that don't have funding and so on. So I think you can show the two sides to this. And so using team science and encouraging, so we've done that. I'm on a multi-PI BII, and because we started in the pandemic, we put a lot of effort into building, even when we've now started to meet in person, but those are always hybrid. Whereas I know that some groups are obsessed with the idea that now the pandemic's over, everyone should meet in person. So I think framing that in terms of being more inclusive offers something that's appealing to people as well.
Thank you.
Hank.
So I'll be quick. I think that as researchers, we have responsibility, just like everyone else, to kind of, do something that's responsive to this whole issue of climate change. And so I think it's something that, if it's done right, with a carrot as opposed to a stick, I can see some really, good things coming out of this. Like institutions want to be the best rated institution in the country in terms of how energy efficient they are, or, how small is their carbon footprint. And The other thing is that, we've done a really good job kind of greening our campuses from just the, facility standpoint and, cafeterias and things like the really easy stuff. Why can't we do it for other things, or at least know what our impact is? And, a good way to get this going is get students on board, because they know how to put pressure on administrations to at least, kind of understand the nature of the problem. So I think a lot of upside to this.
Thank you. All right, I don't see any other hands, but I would like to, I do have I think 3 or 4 minutes. So last, I'm happy to give you back a few minutes so you can get on with your meeting.
Oh,
but,
you have another question,
no.
Kim?
Yep.
Gretchen's put her hand up.
Thank you.
Yeah, Kim, I just have one point that you could make, or that's easy to put in broader impacts, and that is the extreme educational and training value of greening one's research. So, yeah.
Yep. Thank you. This is good. These were good. I've been jotting them down. I know Arnaldo, I think, is on the call. Hopefully he's been helping me to keep notes of your comments, because these are really good. And I do want to, I do want to give Arnaldo an opportunity. I know he's a man of few words, but Arnaldo, did you have anything to add before we close? I wanted to give you that opportunity.
Kim, you put me on the spot, and I'm a man of few words. Thank you very much. But,
he hates when I do that, but I did want to just, yeah.
Yeah, no, I think that it's great to hear both sides of the coin here. And something that really resonated with me today is that we can make an impact, right, as individuals and as scientists. And so I think that I feel that NSF doesn't ask too much from us. So I think that and I'm talking as a researcher, right? Because I'm on loan. I'm a rotator at NSF right now. But I feel that NSF doesn't ask us for too much. So I think that thinking about this issue, I think, would be very exciting and a very educational value, as we heard from people too. So thank you, Kim, for putting me on the spot, but we'll talk about it again.
All right. Thank you. And again, these were excellent suggestions. It's great to get your feedback. I'm happy to hear. It sounds like there's a consensus that you agree that this is an important topic. And as we've heard from you all and other advisory committees, we do have to be very sensitive, to the burden or the any extra work that we put on PIs, other than just really kind of focusing on that research. But to the other point that was made, I do think it's really important to at least increase visibility and awareness of this issue, which is really, I think it's a kind of a spectrum of where we're going here. And we're starting with just increased awareness of this, and then eventually we'll maybe get to a point where it's not even, it's one of the first things we think about when we design our research, when we think about where to place our facilities or how to design them, that we think about minimizing the impact on our environment. So anyway, thank you very much. I have 15 seconds according to my watch, but I do appreciate your time.
Thank you very much, Kim.
I don't want to go, but I appreciate it. Thank you so much.
Thank you.
All right.
Okay, so our last item for today is we're going to prep for tomorrow's meeting with the COO of NSF, Karen Marangel. So Karen has moved her meeting up a little in time for us. So we're actually going to meet with her earlier than we previously anticipated. So we need to kind of just, if we can now, just sort of discuss a few of the key points. I will then pull something together. I've got great notes from everybody already. Thank you to the scribes and to everybody who was in the breakout rooms. So if you remember from last time and other times we've all done this, she'll only make brief remarks, and then we're going to have to be the ones that take the questions to her. So what I think we need to do is to sort of start to think a little bit. We will have a little time to firm them up tomorrow about the sort of points that we want to raise. And I think it's what I'll do then is to sort of assign a couple of people, 1 or 2 people to each point. There's too many of us. If we all try to say something, we'll barely get our names out and then she'll be gone. So we'll try and hit on a few key points. If you remember last time, she's great to talk to, and she is going to converse with us. She's not just going to listen. So we've got to keep it to the things that we most want to convey that excite us and where we think the opportunities are. So remember, we're going to talk about the 2 things that the 2 questions that we had about emergent research areas, but we have to leave a little bit of time for tomorrow when we talk about strategic partnerships, because those will inform these points as well. So what I have, so I'll lead off with this and just put a few things out there. So thinking about most exciting or impactful research areas, we all seem to hone in on a few points. I think the idea of AI in different settings came through again and again. Different people have expressed thoughts about which way we could go with that. So I'll throw this out there. We have a lot of things we could say about AI. What do people think should be our kind of key lead point on that topic in terms of the future of biology? Hank.
Yeah, I think one thing we should emphasize is that, it can't just be that we're handing everything over to AI and computer science. It has to be a partnership, or collaboration, where the biologists are actually, helping the computer scientists to understand a biological phenomenon. Because frankly, without that kind of biology knowledge, it's going to be very difficult for the computer scientists to understand what we're trying to do.
Maria?
A couple of thoughts. One is, that some kind of broad solicitation that doesn't get down in the weeds as to the specifics, but just some collaboration between computer science or statistics and bio, and the many different problems that can be tackled with that. And the second, in terms of partnerships, and I suspect this is already happening, it's really industry that is driving a lot of this. And what comes to mind, for instance, with remote sensing and object recognition is what Google has done for satellite data. I mean, it's just completely changed the landscape of analysis of satellite data. And I suspect that these partnerships are already ongoing at many universities, but just as a kind of ad hoc basis, and to the degree that NSF can be perhaps more disciplined, or put some kind of ideas about what kinds of partnerships do we want, and engage the power of industry and their technology. That would be it would be great, I think.
Okay. Tom.
Yeah, I just, 2 things. One is AI is an incredibly enabling technology, allowing us to discover models as well as use models in connecting data to our understanding. So that's a super important thing. I also want to come back to what Michelle was saying earlier, that we are benefited by AI, but AI will be benefited by a deeper understanding of natural intelligence and natural systems and how they process, acquire, and store information. So I see this as a 2-way street. It isn't that AI is just enabling, but that we may be the bio side of the world may be able to inspire new technologies that have I.
Okay, so that's the sort of, I think that's, I'm assuming this is going to be pretty high on her agenda. So I think she needs to hear it from us in terms of where bio comes into this. I think it would be good to convey that we're excited, we're not scared of it, and that we're all in different ways using it more and more, which I think is key in that. So the next thing that we talked about in terms of what's exciting and impactful is this sort of, I don't know how to put it. I think interdisciplinary is a very shallow, insufficient word to describe this true integration of knowledge areas. So in terms of, for example, understanding traits and phenomes and what defines a system and how the system can adapt to unprecedented timescales and that kind of thing. And this does relate to I think this could be a follow-on because I can't remember who mentioned this notion of modeling plays into this, that these are not, we're way beyond single PI experiments or projects or anything like that. So what do people think in that space is worth bringing up? Rob.
I think it's really important, but I also think it's a massive challenge that extends a lot into workforce development and so on and so forth. I mean, clearly, the era of the Renaissance person is beyond us. Nobody can be an expert simultaneously in all of these disciplines. So we need to develop ourselves and our students to be able to explain the problem to someone in a different discipline who has something like AI that can help. And they have to know enough biology to be able to understand the problem. So this creates huge challenges. And the challenge is growing because we just keep needing to add things on in our training, yet there's this pressure to attenuate the training period. So these are, I mean, this is one of the central conflicts we've been talking about the last couple of meetings. And so I think this is a good mechanism to emphasize that workforce development issue, the student postdoc training issue, which I think is one of the central ones of this time.
Maria.
Yeah, I mean, I also wonder, I mean, there's been, pretty successful efforts, for instance, at the level of institutes and workshops and all that run by NSF in training of statistics for biologists, at least in DEB. There's been, very, very successful things that have been done. And I wonder whether we could do something similar with AI. And also perhaps get away from this notion that I think in some ways we carry the baggage of education that aimed at depth. I was having a conversation recently with a student who was already using a lot of satellite data, and he said, well, should I really understand the optics of satellites? And this was going to be something that was going to take the good part of a year. And I said, well, what do you want to do, right? So do we, how much depth do we need versus width? And, just the ability to use tools. We don't need to be a specialist, deep specialist in every area. We could be a user. So, just those couple of thoughts on how we may proceed with training that is more pragmatic in terms of using the tools, even if we don't have a deep understanding of them.
Okay, Gretchen.
Yeah, well, I think that points, both the last 2 points, Rob's and Maria's, points to the need for team science. We can accelerate our training as long as we train people in different areas, and then they can work on a team together. So I think that what we need to ensure is equal opportunity to become a member of a working team, and make sure that the biology component of that is front and center. So.
Okay. So I think I'm going to sort of summarize this before we break for the day, because I think that when we go through these points, at least my sense is that in each case, we should give an example of some biology that we can see we would advance if we do these things as well, so that it doesn't become too abstracted in the mechanism side of it, so to speak. But I think these are, because I think that's what we all take for granted, that we can see the biology question, but I think it will be important for us to frame a biological question around this as well, so that Karen has something to say. That's Teresa gave us a thumbs up, so we better have a biology question, otherwise she's going to give us a thumbs down and that won't be good. Okay, so the third thing that I had was, and I think this was sort of, and I don't know where NSF is with this, it's kind of moving forward with the sort of next era of synthetic biology. Whether that's something that is still of interest, or it seems that we've got so many tools and so much potential in place. And Maria brought up this idea, for example, of synthetic synapses and things like this, which is really going into the next step of this. And this is naturally going to play into the other thing we're going to talk about, which is risk. So I think this could be important as well. What do people think about this? Is everybody tired of synthetic biology? Do you think, Eric could be, I know Eric, he could be tired of synthetic biology. Let me see.
Well, sorry, Mike. I was just going to say that I see synthetic biology as one of those tools to test hypotheses, as well as more part of the solution box when we have specific problems that need to be resolved. So I think it's important to talk about synthetic biology, but I cannot see it in isolation of everything else that we have been talking. And I think that some of the things that we have been discussing are probably at a higher level than synthetic biology itself.
Yeah, okay, I get that. So for the impactful research, most exciting, what are the is there another one or two topics that people, or maybe one topic? So I think I agree with you, Eric, when I think about it, synthetic biology seems to be a bit more down in the weeds compared to the other two big topics. Is there another big topic that people think we should be presenting?
Mike, can I just make a comment? And it's just that you might want to think about it as a group, how the things that you've been discussing relate to the bigger themes that we've been discussing here at NSF, which is emerging industries, resilient planet, creating opportunities everywhere, and the research infrastructure. So the last topic, the new synthetic biology, that's clearly going to be related to research infrastructure, but it also will have impacts in the other themes as well. So you just might get a little bit more traction with Karen if you think about it within that broader context.
So what were the three again? Because I was starting to annotate them.
There's four. There's resilient planet.
Okay, that's easy.
Emerging industries.
Yeah.
Creating opportunities everywhere. And then research infrastructure.
Okay. All right. So emerging industries, creating opportunities, resilient planet. Yeah, that's good to frame. I now I can. So Simon, do you think it's we can easily frame the question. Do you think it's going to be most effective in the 30 minutes if we frame everything? We frame around those four topics.
No, I don't think so. But it's a lot of what you've been discussing in terms of the AI aspects of it all. That relates to emerging industries. It relates to resilient planet. So I don't think you need to frame it entirely around those, but having that broader context might be helpful.
Yeah, no, that makes sense, because then also the true integration is really resilient planet, and synthetic biology is research infrastructure. And
And a lot of the examples you gave around how you would use AI to solve problems and the biological problems you were solving climate change. So you were solving problems in Resilient Planet. And so making that connection for her will be a little more impactful for us. Thank you.
Okay, I get that. That's good. Thank you, Teresa. Okay, so then in terms of the factors, sorry, Rob.
I was just going to come back to the point that Suzanne has made multiple times about particularly if one emphasizes the quantitative, computational, et cetera, skill set development at MSIs and so on and so forth. That fits into the team science part and really plays into the creating opportunities everywhere.
Yeah. Okay. So in terms of realizing these goals, I think it's going to be really important because we've already started to bleed into tomorrow's questions about partnerships. So that will kind of feed into this. So I think we talked a lot initially, and we all talked in the breakout groups about the training and career advancement and so on for students as part of the group that will help realize these goals. So how high do we put that? Do you think that's our number one priority here? Because it is a challenge that everyone is currently facing more and more. Eric brought it up, Suzanne brought it up, others have brought it, Rob brought it up. Eric.
Yeah, my concern with that, and I said that when we had the breakout groups, is that we can patch, but I think that the issue of training is one that goes way bigger than just anything we can do within the NSF or whatever. I mean, I think our entire education system will have to be changed. So we can certainly try to find solutions in the short term. That's probably what we have been doing for the past 50 years. But at some point, there will have to be something bigger will have to be done to really come up with a sustainable educative system that is up to the dates of today. So I mean, yes, it's a priority because without qualified people, we cannot do anything, right? But I don't think the problem is easy. I don't think there is any single solution.
So that's I mean, I think that the fact that it's now it hasn't come to a point that I think maybe the way to frame it, I don't know, NSF people can tell me this, is that how much you will achieve from the exciting and impactful research that we're going to suggest, that the amount of outcomes is going to depend upon how much we can effectively staff those projects. I don't really know how else to put it. I mean, no one has a good solution currently to this. Let's be honest. It's not getting easier.
Well, and I think just pointing that out, I mean, this is there's challenges and there's opportunities here. And, and just for some background, I mean, Karen's a statistician, and she used to be the assistant director for the Education and Human Resources Directorate, which is now the Education Directorate. So she's interested in these things, and she would like to engage in some of these things. And that may be an opportunity for a real back and forth between you and Karen on this particular topic, on what might be a path forward.
Yeah. Gretchen.
Yeah, one thing occurs to me, and it's, you said staff I actually think that what we need to be inspiring is a group of people to ask these questions and to come up with to ask what is the next exciting thing in science that we should be addressing. And when I look at my students, my undergraduates, what they actually, the only sort of novel thing that they've become really excited about is computational biology. And so I think that what we want to do is I think it's in our capacity to excite people. And I think that we can excite these students when they come, but it has to be something that they can do and that they can do in many areas afterwards. So.
Yeah, and that's something we brought up, is that it's about not over defining the options that we provide them from this. I think that's, yeah. Maria.
Yeah, I mean, it touches on the theme that you just brought up. I think universities right now, particularly with the increased cost of students, are facing this issue of, sometimes the number of students is determined by the TA shifts, the needs that they have for teaching. And the length of the program often was created with the assumption that the student is going to go into academia and they need a certain length of education. And it could be far more streamlined if the student has a clear career goal that does not necessarily go to academia. I mean, we've had these discussions about the humanities, not so much about sciences at my university. But I think we could have a discussion with her about what would that look like and what kind of opportunities could NSF create to facilitate that. And it come to mind, for instance, I had a student that did internship in one of the national labs. That was a great experience. Or an internship in industry that is supported with some kind of partnership from NSF to accelerate that process, right? To sort of say, this is a great career option. And in fact, most of you are not going to be professors and you're going to be doing something else. And how can NSF accelerate that and in some ways destigmatize it? And I think also from the point of view of income and length of program, which I think is a big deterrent for people to choose to either become a graduate student or a postdoc because you're making no money for a long period of time. That could be an incentive to come and get degrees. And so don't know that it would help us with research necessarily, but it seems that from the point of view of the students and postdocs, it would be a good thing.
Tom.
Yeah, it's sort of drawing a little more on what Maria just said. Is my read on the undergraduates is they are vastly more interested in building computational skills, even the life science ones, than the faculty are. So I'll start right there. And that the other thing that they're looking for, that industry is looking for, are what are called, we talked about this briefly, stackable certificates. These are, can you get your biochemistry major with a certificate in early machine learning? This actually is like internships, but it gives you employment opportunities that would otherwise be inaccessible. So I think they're there, they're ready for it. I think it's not that difficult to learn, and I think the community is waiting for the faculty to lead on this, but the students are there. So I think stackable certificates, cross-training is not as difficult as we're imagining. I think they're hungry for it.
Okay. Hank.
Yeah, so the way I interpret the attitudes of students today, the younger generations, is that they're looking at us as professionals and how hard we work, and they're saying, I don't want to be like that. And I just think we have to find new ways to excite them and capture their imagination. I do agree with Tom that, they are very eager to learn, to develop computational skills, because they see that as a way of applying themselves to jobs that they can get that pay good money right away, not go down this long path, to being graduate students and postdocs and then academic professionals that work so hard. So I just think we need to come up with some new ways of exciting students about the kind of research that we're doing I find that the ones that really get excited at research want to kind of stick with it in some form or fashion. And, that would extend to the postdoc years, even if they don't want to become academic professionals in the end. They could work at national labs. They could produce television documentaries. I mean, there's all kind of ways that they could spin it. But that's just what I think how we have to capture their imagination.
Okay. So the last point I'm going to bring up, which I think is all part of this, because I think it touches on everything in terms of a challenge to advancing this, is that a lot of what we're talking about involves funding things with a little more, I'm not going to call it riskier, with a little more of an open mind, maybe is a more positive way to put it. So I know that Maria Pellegrini had mentioned this at length, what she's encountered. And I know that the people at NSF are open-minded, but we as academics aren't. And so we might need a little more, as university academics, we're not, I should say. We're all academics, but we're just not very good at this, about risk assessment, risk outcomes. And this might play a little bit more into the partnerships conversation tomorrow, but what does everyone else think? I think this has come up a little bit, and I think it could be worth putting forward. Maria.
I think the biggest part of there's two aspects to risk: the good kind and the bad kind. The bad kind is if something violates the second law of thermodynamics, you got to think about it a little bit more better. If on the other hand, it's risky because we simply don't know yet, then that's a good kind of risk. But what that kind of risk entails is willingness to fail. You have to be willing to have a certain piece of the portfolio not work, and that's hard.
Rob.
At every one of these meetings I've been to, we've talked about communication of broader impacts to panelists, for example. And I think we need to think about the same in this context, how to get panelists to think more broadly about risk.
Hank?
So I thought the whole thing about risk was not that, it would cost a lot of money and that money would be wasted. It's that, and this was like what NSF was saying, the agency would make small investments in things that were risky because they had a potential for a high payoff. It was worth the investment to take that gamble. So I'm talking about like eager funding or some kind of, planning grant or something like that to go ahead and prove your concept. And then, it's worth it to then come back and get more funding. So, yeah, I think that's the kind of risk that kind of model works really well, and it's not very expensive.
Okay. Eric.
Yeah, but on the other hand, I think that to solve really challenging problems, small investments is probably not enough. So we were talking about 5% risk versus 95% risk, right? And I think that probably what we are talking about here is shifting from the 5% risk to the 95% risk. And that involves probably bigger commitments as well as longer times. I mean, eager is what, 2 years, maybe 3 at most, with a fairly modest amount of money. Yeah, I mean, you can test some provocative ideas, but you can touch some provocative ideas. You cannot really solve them. So I'm not so sure that we have the right risk model right now. And I think it's something we really need to think about us as to whether maybe making longer investments, changing even the reward. I mean, thinking about the workforce. What is the driver for many of the people to want to do this kind of research? That's not something we're thinking. I mean, we think that everybody has the same desire to do it as we do, but that's not necessarily true. And I think we need to think harder about what is the reward for the people that are going to be participating in these projects at the end of the project. It's not just answering questions.
So I really agree, because I don't know, I mean, I'm going to date myself significantly, but I don't know if you remember when Christiane Stein-Volhart won the Nobel Prize for working with zebrafish. She said I couldn't have won it anywhere except where I did the work, because they left me alone for 10 years. Kind of said it. I mean, that's a very different model that in the US you would struggle to fund. So, all right, I think we've got more than enough material already, and we have another session tomorrow. So I hope you don't mind if I email some of you and ask you to say a few words about what we've brought up already. I won't do it now in the Zoom, because I don't want to do a kind of shaming you into saying yes type thing. That would be inappropriate. Okay, I've been told by Simon that there's really quality snacks and booze on the top floor. Is it on the top floor, Simon? Are we still recording?
12th floor.
Please delete that from the recording. Okay.
We do have special permission to have Elsa.
We're going to adjourn for the day. As I said, I'll do a couple of follow-up emails about a few things. But thank you. I thought today was really, really productive. And I appreciate everyone at NSF for setting up this model. I thought it was really, really, really interesting. You've given us a lot to think about.
Well, great.
Right,
thank you. And we'll see how it goes tomorrow. Thanks, everyone.
Yep. All right. Thanks.